Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. Research is our strength. We cannot face this alone. We must stand together to make our vision a reality. That drives us towards the future. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity, filled with miracle and wonder. We and in to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, research organization for governance, economy, and community welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with two main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs. Tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. Co-working space, meeting rooms. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology, practices, and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation. Knowledge is the foundation, and to be put in praxis for the sake of the nation. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
For more than 7 decades, PLN has carried out the state's mandate to electrify the whole Indonesian archipelago. PLN is entering a new chapter in its transformation, aiming to become not just a power and utility company, but also a technology company based on innovations. All of this is to improve service quality, strengthening the domestic industrial ecosystem, and increasing competitiveness in the global stage. Based on innovations. All of this is to improve service quality, strengthening the domestic industrial ecosystem.
Ini waktunya akselerasi. Buat wujudin mimpi itu harus rame-rame.
Rame ini.
Yes! Mantap! Gak cuma sekedar wujudin mimpi, tapi ciptain inovasi. Kita berkolaborasi biar ngasih impact positif buat bangsa Indonesia. Ayo, wujudin swasembada energi dengan terus berakselerasi tanpa henti. Pertamina, energizing the acceleration, energizing you. Positif buat bangsa Indonesia. Ayo, wujudin swasembada energi dengan terus berakselerasi tanpa henti. Pertamina, energizing the acceleration, energizing you. Positif buat bangsa Indonesia. Ayo, wujudin swasembada energi dengan terus berakselerasi tanpa henti. Pertamina, energizing the acceleration, energizing you.
Indonesia is the most beautiful land in the universe. The land where we were born. The nation where we grew up. So many colors that live together in peace. With a million timeless treasures. With an abundance of natural wealth. Indonesia is not just wonderful. Indonesia is a wonderland.
Sugeng Rawuh, selamat datang di Hotel Tentrem Yogyakarta. Keselamatan Anda adalah prioritas utama kami. Mohon perhatian Anda mengenai prosedur keamanan dan keselamatan saat terjadi situasi darurat. Seluruh area di Hotel Tentrem Yogyakarta telah dilengkapi dengan peralatan keselamatan dan juga sistem kontrol yang dipantau selama 24 jam. Setiap ruangan dilengkapi alat pemadam kebakaran, pendeteksi asap, alat percikan air, sistem pengumuman publik, dan juga teknologi ultraviolet C pada saluran pendingin untuk menjaga udara terbebas dari bakteri dan virus. Tim tanggap darurat Hotel Tentrem Yogyakarta siap siaga selama 24 jam untuk melakukan evakuasi, pertolongan pertama, dan pemadaman kebakaran. Apabila terjadi situasi darurat seperti kebakaran, gempa bumi, dan lain-lain, mohon untuk tetap tenang dan mengikuti petunjuk tim tanggap darurat kami. Dengan tidak menggunakan lift, mohon keluar dari gedung dengan pintu keluar darurat. Pintu tersedia di setiap lantai dan akan mengarahkan Anda untuk menuju titik kumpul. Demi keamanan bersama, mohon untuk menjaga barang berharga Anda. Terima kasih untuk kepercayaan Anda. Selamat beraktivitas dan semoga ketentraman selalu ada di dalam hati Anda. Mohon untuk menjaga barang berharga Anda. Terima kasih untuk kepercayaan Anda. Selamat beraktivitas dan semoga
Excuse me, to the committee, Nanda. Can you please come, Nanda? We would like to also request participants to make sure that your mobile phone is in silent mode so that it won't distract this event. Thank you. Ladies and gentlemen, we would like to invite you to come to this ballroom because our agenda is about to start. Ini Mas Adam. Good morning, selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, it is an honor to be here with you today. My name is Novi, and I will be your MC for the 2 days ICCEA conference. Welcome to ICCEA 2025, the International Conference on Sustainable Energy Engineering and Application, with the theme Green Manufacturing, Integrating Renewable Energy and Advanced Testing Technology for a Sustainable Future. This marks the 12th edition of ICCEA, proudly presented by BRIN, National Research and Innovation Agency Indonesia. Please give warm applause to BRIN, National Research and Innovation Agency Indonesia. We would like to welcome you to Yogyakarta, a city where tradition and creativity come together naturally. With its rich cultural heritage, Yogyakarta offers a unique and authentic experience. We hope you not only enjoy this conference, but also take the opportunity to explore the beauty of this city. First and foremost, allow me to extend our warmest greetings to our esteemed guests. Dr. Laksana Trihandoko, Head of BRIN, National Research and Innovation Agency, Indonesia. Professor Cuk Supriyadi Alinandar, Head of the Research Organization for Energy and Manufacturing, BRIN. Head of Research Centers under the Research Organization for Energy and Manufacturing, BRIN. Our keynote speakers, Dr. Adroit Torik Nur Fajar from International Institute for Carbon Neutral Energy Research, Kyushu University, Japan. Professor Anneli Petrisan from Laboratory of Study and Research on Wood Material, University of Lorraine, France. Dr. Ismail Abdullah Al-Faleh, General Director of NMCC, or SASO, Standards, Metrology and Quality Organization, Saudi Arabia. Dr. Masahiro Hori from Research Institute of Electronics, Shizuoka University, Japan. Mr. Onodera Hitoshi from Japan Automobile Standards Internationalization Center. Dr. Tetsuya Nikuni, Director of the Environment Research Department, National Traffic Safety and Environment Laboratory, Japan. Mr. Tim Lehman from PAR Instrument, USA. Mr. Rahmat Hidayat from PT Hyoki Electric Indonesia. Chairman of ICCEA 2025, Muhammad Hoirul Anam, PhD. Our generous sponsors, PAR Instrument USA, PT Sarana Laboratorium Instrumentasi, PT Hyoki Electric Indonesia, PT PLN Persero, PT Pertamina Persero, PT PLN Puslitbang, PT Geodipa Energi, Biro Klasifikasi Indonesia, PT PLN Indonesia Power, PT Vale Indonesia, PT Bank Pembangunan Daerah Jawa Barat dan Banten. Thank you for your invaluable support in making this event possible. We look forward to continue collaboration in the future. To our event partners, Gajah Mada University, UPN Yogyakarta, Universitas 11 Maret. To our co-organizer, PT Numedia Atria Dinamika. Finally, to all distinguished participants of ICCEA 2025, thank you for being part of this conference. Let's give a warm round of applause for everyone. Ladies and gentlemen, our agenda today mainly consists of conference report and greetings, plenary sessions with keynote speakers, followed by oral presentations in parallel rooms, both offline and online. We kindly ask for your cooperation to ensure that this conference proceeds as planned. Before we proceed, to honor the host country of this conference, we would like to sing the national anthem of Indonesia, Indonesia Raya. Ladies and gentlemen, please raise. Please be seated. Distinguished guests, ladies and gentlemen, to understand more about ICCEA, I would like to invite the chairman of the 12th ICCEA 2025 to share with us. Please welcome Muhammad Hoirul Anam, PhD.
Bismillahirrahmanirrahim. Good morning, ladies and gentlemen. On behalf of all organizing committees, I will start my report by welcoming several people who make this event possible. So please bear with me for a little while. The Honorable Dr. Laksana Trihandoko, Chairman of National Research and Innovation Agency or BRIN, Professor Cuk Supriyadi Alinandar, Chairman of Research Organization for Energy and Manufacture, all 7 heads of the research center in the Research Organization for Energy and Manufacture, Dr. Teguh Mutaki, Tata Sutardi, PhD, Mahfud Aluda, Dr. Hens Saputra, Nugroho Adi Sasongko, PhD, Dr. A. Muharram, and Dr. Bijo Kongko. Our keynote speakers and industrial talk speakers, Dr. Adroit T.N. Fajar, Professor Anneli Petrisans, Dr. Ismail Al-Faleh, Masahiro Hori, PhD, Dr. Tetsuya Nikuni, Mr. Onodera Hitoshi, Mr. Tim Lehman, and Mr. Rahmat Hidayat. Next, I would like to welcome our sponsors, Par Instrument USA, PT Hioki Electric Indonesia, PT Geodipa Energi, PT Pertamina Persero, PT PLN Persero, PT Vale Indonesia, PT PLN Puslitbang, PT PLN Indonesia Power, PT Biro Klasifikasi Indonesia, and Bank BJB. Also welcome to our partners, Mr. Andi Setyanugroho from PT Numedia Atria Dinamika, and representative from IEEE Indonesian section as our technical co-sponsor. And lastly, welcome to all presenters and attendees who joining us both online or offline. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, all praises and gratitude. Let us express to the mercy of Allah Subhanahu wa Ta'ala, because with His blessing, we can attend 12th International Conference on Sustainable Energy Engineering and Application, ICCEA 2025 in Yogyakarta, Indonesia. Ladies and gentlemen, ICCEA 2025 will focus on recent research trend in the field of new and renewable energy, sustainable transportation, green manufacturing, MSTQ in manufacturing, and green maritime technology. So in this conference, researcher, engineer, industry leaders will share different topics related to the renewable energy integration in industrial processes, advanced testing technology, and its application in the smart manufacturing to realize sustainable future. Following the success of the ICCEA 2024 in Bali last year, which focused on energy sector, this year, ICCEA shift its attention to the green manufacturing, where the primary theme of this year is green manufacturing, integrating renewable energy, and advanced testing technology for sustainable future. Ladies and gentlemen, on behalf of all committees, I'm very grateful to have keynote speakers from a reputable international institution to enrich our discussion in ICCEA 2025. In addition, I would like to deliver our respect and appreciation to all scientific committees for their dedication in maintaining the quality of the submitted manuscript in this event. Regarding this conference, I'm also pleased to announce that around 135 topics will be presented in this conference, where 48% are coming from non-BRIN presenters. This number represents the collaboration results with distinguished international institutions such as University of Twente, Netherlands, Ukrainian State University of Science and Technology, University of Queensland, Australia, National Measurement and Calibration Center, Saudi Arabia, National Tianjin University of Technology, Taiwan, University Technology Malaysia, Mara University of Technology Malaysia, and Sirindon International Institute, Thailand. Ladies and gentlemen, This conference will start with keynote session and feature with 5 parallel sessions, which comprising 2 offline sessions and 3 online sessions. So during the presentation time, I encourage everyone to be active during this session, whether it is asking questions, sharing experiences, or offering opinions. The more we engage, the more insightful we get from this discussion. In the second day, which is tomorrow, we will host a series of industrial talks. The representatives from various industries will share their experience and insight on sustainable energy and advanced testing technology towards green manufacturing. As a chairman, I would like to thank to all organizing committees and co-organizers for all the hard work and dedication to this event. Lastly, I would like to extend our gratitude to all sponsors for their support to make this conference a resounding success. We also thank to the IEEE Indonesian section, especially for Power Energy Society, for their effort in providing technical co-sponsorship to this conference. I hope that this event can foster meaningful collaboration and bring positive impact in your professional career. Once again, I want to remind to everyone that we gather here for the sake of knowledge, that only not improve our understanding, but foster curiosity in the science and innovation. So I do really hope that each of you lives with the new insights and inspiration to continue the journey of discovery. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Anam. ICCEA participants, next speech is from the host of this conference, the Research Organization for Energy and Manufacture, BRIN. Please welcome Professor Cu Supriyadi Ali Nandar.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, good morning, and warm greeting for everyone. Before we start the conference, let us take a moment to express our gratitude to Allah Subhanahu wa Ta'ala, the God, for His blessing, allowing us to gather here for His wonderful event in wonderful city, Yogyakarta. I would like to extend my highest appreciation to our distinguished keynote speech. First, Dr. Adroit Fajar from International Institute for Carbon Neutral Energy Research, Kyushu University, Japan. I was graduated from Kyushu University too in 2010. And then the second is Dr. Ismail Al-Faleh from General Director of National Measurement and Calibration Center, SASO, Saudi Arabia. Professor Aneli from Laboratory of Study and Research on Wood Material, University of the Lorraine, France. Yeah. Professor Masahiro Hori from Research Institute of Electronic, Shizuoka University, Japan. Onodira Hitoshi from Japan Automobile Standard Internationalization Center, also the belong to Nissan, yeah. Thank you very much, Dr. Hitoshi, and also Dr. Tetsuya Nikuni from Director of the Environment Research Department, National Traffic Safety and Environment Laboratory, Japan, as the only keynote for online, yeah, this one, okay. And I also would like to extend my appreciation to keynote speaker from Industrial Talk Session, Mr. Tim Lehman, as Vice President of Sales and Marketing of Power Instrument USA. Thank you very much. And also Mr. Rahmat Hidayat as Manager of Product Business Strategy from PT Hyoki Electric Indonesia. Furthermore, I also warmly welcome our esteemed guest, Insinyur Sutrisno, MSc PhD, as the head of Electrical Engineering Department Universitas Negeri Surakarta, WNS. Dr. Adi Ilham, the head of Chemical Engineering Department, UPN. Professor Arif Nur Afandi from IEEE Indonesia section. Insinyur Sri Wulan as the Marketing Director PT Tema Sarana Laboratory. And BRIN Academy Community, faculty member and industry practitioner from who have joined us today. It is truly an honor for me to open this prestigious international conference. With this, the topic of this year is the green manufacturing, integrating renewable energy and advanced testing technology for sustainable future. As a brief background, ICSEEA has now reached its 12th edition, serving as a vital platform for scholars, researchers, and industry leaders from BRIN universities and institutions worldwide. Following the success of the ICSEEA 11 in Bali last year, which focused on the energy sector, this year's shift its attention to the green manufacturing. This shift reflects the growing urgency to enhance sustainability in industrial processes as climate change and environmental concern become more pressing. So industry must adopt the renewable energy solution, advanced testing technology to ensure the efficient and eco-friendly production method. At BRIN, we are fully committed to collaboration. As the head of the Research Organization for Energy and Manufacturing, I am proud to share that our organization consists more than the 1,000 scientists and engineers, producing over 500 journals, maybe, in these years, and more than the 150 patents in this year annually, I mean. So we are really to be the best innovation partner for industry, offering joint development or co-development program, partner licenses, and research dissemination to help the solve real-world industrial challenges. So through this conference, we aim to showcase innovation solutions, encourage knowledge exchange, and foster collaboration that will drive the industry toward the greener and more sustainable future. As the head of Research Organization for Energy and Manufacture at BRIN, I sincerely hope that this event spark meaningful discussion and pave the way for the groundbreaking research and industrial advancements. Before concluding, I would like to express my gratitude to our sponsor. Please join me to giving big round applause to our sponsor. Yeah. First is Par Instrument USA. PT Sarana Laboratorium Instrumentasi. Itu ya. PT PLN Persero. PT Pertamina Persero. Also the PT PLN Puslitbang, PT Geodipa Energi, PT Biro Klasifikasi Indonesia Persero, PT PLN Indonesia Power ya, PT Vale Indonesia, and Bank PJB, PT Bank Pembangunan Daerah Jawa Barat and Banten. Your support has been a value in making this conference success. I wish the all participants a productive and insightful conference. We looking forward for the inspire groundbreaking ideas, collaboration, and contribution to the advancement of sustainable energy and green manufacture. And also thank you very much for the committee for excellent preparation in this wonderful conference. And I wish you all fruitful and engaging conference. And I close with pantun, ikan hiu makan tomat. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Chu, who is always great with his pantun. Pantun is Indonesian culture where the words is rhyme and then have some beautiful meanings usually. Okay, once again, please give applause to Professor Chu, our head of research organization for energy and manufacture. Ladies and gentlemen, we will now proceed with the opening speech by the head of BRIN. Due to prior commitments, he is unable to join us in person today. However, he has kindly prepared a video of his speech in advance for this conference. Please proceed.
Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen, distinguished guests, esteemed colleagues, honored speakers, delegates, and good morning to our audience joining us online from around the world. It is a great honor for me to welcome you all attending the 12th International Conference on Sustainable Energy Engineering and Application, ICSEEA 2025 in Yogyakarta, Indonesia. On behalf of the National Research and Innovation Agency, I would like to again extend our warmest greetings to all of you, and this gathering represents the collective efforts of individuals, organizations, and institutions from across the world, and I'm truly excited to see so many brilliant minds coming together to explore, to discuss, and to share innovative ideas. Keynote speakers, distinguished guests, and all participants, this year's conference theme, Green Manufacturing, Integrating Renewable Energy and Advanced Testing Technology for Sustainable Future. This marks a significant milestone of our commitment to implement green manufacturing for a sustainable future. Indonesia has been actively pursuing policies to facilitate energy transition and promote green manufacturing in line with global sustainability goals. The government of Indonesia has recognized that transitioning to clean energy and adopting green manufacturing practices are very critical for both economic growth and environmental pressure. Following those issues, Indonesian government has shown a strong commitment to green manufacturing and energy transition, focusing on sustainable practices and the reduction of environmental impact. As a part of its broader environmental goals, Indonesia is moving toward cleaner energy solutions and promoting energy efficiency. To ensure that new energy technologies are viable, Indonesia has established standards and testing protocols for clean energy technologies. Advanced energy testing for a sustainable future is essential to ensure that energy system, technologies, and processes are optimized for long-term environmental, economic, and social benefits. As countries, industries, and organizations strive to transition toward cleaner and more efficient and sustainable energy solutions, advanced testing technology plays a critical role. Indonesia recognizes that advanced testing is crucial to ensure efficiency of clean energy technologies and the sustainability of manufacturing process. To promote more green manufacturing, Indonesia has developed policies that encourage industries to adopt sustainable practices while testing the environmental impact of their processes and products. Our government requires industries, in particular heavy manufacturing, to conduct an environmental impact assessment before commencing large-scale projects. This will ensure that manufacturing processes minimize environmental harm and comply with regulations and use energy-efficient technologies. Ladies and gentlemen, within BRIN, we are deeply committed to conduct advanced scientific research and innovation to address challenges faced by individuals, societies, and industries. As we gather here in Yogyakarta, Indonesia, for the next 2 days, we will be honored to be among experts, researchers, and industry leaders from around the globe. Together, we will explore how cutting-edge research and strategic partnership can drive positive change and foster a more resilient and inclusive global economy. This hybrid conference, encompassing both online and offline participation, brings together the very best minds across disciplines. Let's use this event to facilitating the exchange of ideas, research findings, and case studies to advance the field of energy, manufacturing, and advanced testing technology. Secondly, also providing a platform for professionals, researchers, and industry leaders to increase networking and collaboration and also exchange the knowledge. And next, showcasing also the discussing innovative insight and methodologies that will improve efficiency and sustainability in energy and manufacturing sectors, and also addressing regulatory requirements and ensuring that testing practice meet legal and safety standards globally to maintain reliability in energy production and manufacturing processes. Ladies and gentlemen, BRIN as the only National Research and Innovation Institute in Indonesia is a combination of research institutions and research entities that supports the Indonesian government in realizing the clean energy target through our role as a research agency in Indonesia. BRIN also plays a role as a supporter of science-based policy at both the central and regional government levels. Furthermore, BRIN is also a funding agency in strengthening the national research and innovation ecosystem. I extend my warmest gratitude to all the participants, sponsors, and organizers who have made ICSEEA 2025 a resounding success. Let us exploit this opportunity to learn, to connect, and to collaborate for a sustainable and bright future. Once again, we would like to thank, and we hope that this event will run well. Concluding my remark, I hereby declare the 12th International Conference on Sustainable Energy, Engineering, and Application, ICSEEA 2025, officially open. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Waalaikumsalam warahmatullahi wabarakatuh. Please give round of applause for Dr. Laksana Trihandoko. ICSEEA participants, Yogyakarta, a city on the island of Java, renowned for its rich traditional culture. To celebrate this cultural heritage and to express our gratitude for your participation in this conference, we are delighted to present a traditional dance performance, Gambyong Pareanom. Allow me to introduce this dance to you briefly. Gambyong Pareanom originates from Central Java, Indonesia. This traditional dance is performed by female dancers, characterized by graceful, gentle, and elegant movements that embody the refined qualities of Javanese culture. This dance is typically performed on various occasions, such as weddings, welcoming guests, official receptions, harvest celebrations, and more. Now, please join me in giving warm round of applause to welcome the dance group from Unit Kesenian Jawa, Gaya Surakarta, Gajah Mada University, Gambyong Pareanom. Please come. Please give applause to our dancers. Ladies and gentlemen, we will now proceed with a photo session. And for this photo session, firstly, we would like to invite the representative of our sponsors who are present today to come to the front. First is Thermalindo Sarana Laboratoria as representative of PAR Instruments in Indonesia, PT Sarana Laboratorium Instrumentasi, PT PLN Indonesia Power, PT PLN Persero, and PT Geodipa Energy. And if more sponsors representative already present, please come to this front. We would like to present to you humble souvenirs from ICSEEA 2025. As a gesture of our appreciation, we would like to present you some special souvenirs. We would like to invite Professor Chu as the head of Research Organization for Energy and Manufacture BRIN, also accompanied by the chairman of ICSEEA, Dr. Anam. Please come to the front. Maybe down here is better space. Down here. Thermalindo Sarana Laboratoria, representative of PAR Instruments Indonesia, PT Sarana Laboratorium Instrumentasi, PT PLN Indonesia Power, PT PLN Persero. PT Geodipa. We Okay. Ladies and gentlemen, here we come to our next agenda, is the plenary session. For this plenary session, we will have 2 keynote speakers, and this session will be chaired by our moderator. Thus, I would like to invite our moderator, Dr. Teguh Mutaki, and our keynote speakers, Dr. Adroit Fajar from International Institute for Carbon Neutral Energy Research, Kyushu University, Japan, and Professor Annelie Petrisan from University of Lorraine, France. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Ladies and gentlemen, it is my honor to stand here among of us. It's a great pleasure, and welcome to everyone joining the 12th International Conference of Sustainability, Energy, Engineering, and Application 2025. So my name is Teguh Mutaki. I'm here represent of the Research Center for Testing Technology. It's part of Research Organization for Energy and Manufacture BRIN. I'm here as your moderator for this first keynote session. And it is my pleasure to guide you through this exciting part of our event today. So as you know, the theme for today's session is green manufacturing, integrating renewable energy and advanced testing technology for sustainable future. This topic is all about finding solutions to combine renewable energy, modern testing technologies to create industries that are more efficient and environmentally friendly. So to dive deeper into this important issue, we are honored here to have 2 distinguished keynote speakers who are, of course, they are leaders in their respective fields. So ladies and gentlemen, it is my great honor to introduce to you the first keynote speaker here, Professor Adroit Fajar. Please give him a round of applause. So Professor Fajar is a leading figure in the field of chemical engineering, sustainable energy, and advanced material. He was graduated from Department of Applied Chemistry, Kyushu University, Japan, and currently serves as assistant professor at the International Institute for Carbon Neutral Energy, Kyushu University. And the next one is Professor Annelie Petrisan. She is a full professor in process engineering and energetic material at the University of Lorraine, France. So please give her a round of applause for Professor Annelie Petrisan. So, yes, this is the curriculum vitae for Professor Annelie Petrisan. Currently, she is a full professor in process engineering and energetic materials, University of Florence. Since 2021, he served in 2022, I mean, served as University of Lorraine, IUT Epinal. And yeah, you can see around here. He graduated in 2001 in PhD of Mechanic and Energetic in University of Nancy. So let's start the first session. I'm supposed to be your moderator, and Professor Adrian Fajar, maybe you will have around 25 minutes. Professor Adrian Fajar will present the topic which entitled Advancing Molecular Design for a Sustainable Future with Generative AI. So please, Dr. Fajar, the floor is yours.
May I stand up?
Yes,
of course.
sure. And if it's easier for you to see the screen, you can also go down here if it's, or you can stay at the podium or hold the laptop over there. You can see also the screen from there.
Yeah.
And the laser pointer, do you need one? It should be somewhere over there. No? Okay. We'll try to find the laser pointer. It should be somewhere. Maybe someone move it. Anyway. Already? Okay. Okay, please wait a little bit.
Ambil di bawah doang. As your convenience. Di sini aja.
Shall we show a slide of? Okay. Oh. Okay.
Yeah, it's working. Okay, yeah. Thank you very much. That was a really kind introduction. And good morning, everyone. I'm Adroit Fajar from Kyushu University. And first of all, I would like to just express my gratitude, and I really appreciate the invitation to be here. It's my honor. And today I'd like to share my experience, perspective, as well as our latest study on how to use generative AI for designing organic or inorganic materials at the molecular level. But before we delve into the details of our study, let me just quickly introduce my institution. So, about several years ago, the Japanese government launched this program called WPI. It stands for World Premier International Research Center Initiative. And this program consists of many institutions across Japan. And one of them is this one. This is the place where I do my research. We call it as ICSEEA, International Institute for Carbon Neutral Energy Research. And this one is located at Kyushu University in this Fukuoka city in Kyushu Island. So if you are planning to go to Fukuoka city, just let me know. I would be very happy to be your tour guide. So what do we do? As the name suggests, we are working on carbon neutral energy research. So this is a very big challenge. So we are working on a variety of technologies, starting from solar cell, battery, fuel cell, hydrogen production, hydrogen storage, as well as CO2 capture. Basically, any technologies that can contribute to achieve the net zero by 2050. And we also love collaborations. Historically, ICSEEA was formed due to the strong collaboration between Kyushu University and University of Illinois in the US, but we also collaborate with many other institutes across the globe in the Europe, China, US, and including in Indonesia. So far, we've been working with Bandung Institute of Technology, ITB, but of course, I would be very happy if we can collaborate more with other Indonesian research or academic institutions. So, okay, that was just a quick introduction about ICEEA. So let's move on to the focus of our group. So as shown here, the focus in my group is at the intersection of applied chemistry and artificial intelligence. On the chemistry side, so far we've been covering topics like green solvent, metal extraction, membrane, catalysis, zeolite, hydrogen, and also CO2 capture. And on the AI side, so far we've been using a language model, adversarial network, autoencoder, diffusion model, transformer, Bayesian, and also transfer learning. So sometimes we also use more traditional approach like just regression, classification, random forest, but our main focus is for a more complicated neural network like as shown here. And I feel that working at the intersection of these two different fields can really speed up the innovation and discovery, and also invention for useful technology that can solve problems in our society. And throughout this presentation, you'll see the paradigm shift in molecular design, starting from the conventional way where usually a chemist or a material scientist needs to propose or design something, crystal structures or molecular structures, and then we do years of experiment in the lab to decide it is good or it is bad. And starting from maybe a few years ago, there is a major trend in scientific literature. So if you just Google it, there's so many papers about using machine learning to accelerate the discovery in many different fields, including chemistry and also material science. Because using machine learning, we can, after we design something like for example, molecular structures, then we can instantaneously decide it is good or bad using the power of predictions. Of course, with some margin of error and uncertainty, but this is really useful for speeding up the screening process. But now we have this very disruptive technology called generative AI. So I guess it's about 2 years ago, like OpenAI launched ChatGPT and everybody was freaking out because we never thought the language model, it's a chatbot actually, could be very intelligent. And many experts believe maybe next we don't need to design something. We can just the AI to design it for us. So usually we refer this as the inverse design. Usually we go from structures to the properties. And now we can go from properties or function and ask the AI to find the structures for us. So for example, we want to design a molecule for CO2 capture and the AI will design it for us. And this is faster than the traditional machine learning model. And this storyline is a global trend, but also my personal journey actually, because I'm actually an experimental chemist. So I used to do a lot of experiments in the lab, but now I'm involved in many AI data science projects in Japan, and especially using the generative model. So throughout this story, so I will share my experience going from conventional chemists that do something in the lab and using AI in day-to-day experiments. So let's start from the conventional one. So it's about 7 years ago. And this is how we designed a new chemical in our lab. So in this case, the context is we wanted to design something for the field of metal extraction because it's very useful for metal mining industries. And in our lab, we proposed this chemical. We call it as ionic liquids. And we believe this can be useful for extraction of precious group metal like platinum and so on, useful metal. And then we had an agreement with this chemical company, Nippon Chemical Industry, and they manufacture this chemical. And then this is just an illustration. We tested the performance, and as shown here, we can have these chemicals. It turns out to be a very good extractant for platinum, palladium, and rhodium. But this takes maybe a year to test this. And then following this promising result, we further developed our technology by converting this new chemical. This is in a liquid state. And then we converted this chemical into a membrane. And at that time, we had a collaboration with Toyota to recover the catalyst from a car. So the combustion catalyst usually consists of precious group metals like platinum, palladium, rhodium. These metals are very expensive. So we need to recover it from the used car and also spent catalyst that has been deactivated. And after, again, years of optimization, we finally found the perfect condition to recover platinum, palladium, and rhodium in a very high purity using this membrane technology. But my point is, it takes maybe more than 3 years. It's about 3 years. Actually, this is my entire PhD. So I spent 3 years to optimize this technology and just working with a very specific one chemical. So it's a very long process, actually. And then after graduated, I had an opportunity to study machine learning in a little bit early. So before all of this hype in the media. So, and then I had an opportunity to study machine learning, and I just submit a proposal to the Japanese government. We can integrate machine learning and to the field of metal extraction. And we got the funding, and this is the idea. So instead of just working on a very specific chemical, just one chemical, let's design more than 100 chemicals. So if we are going to assess this chemical experimentally, so I spent 3 years to assess one chemical. So if we have 100 chemicals, so roughly we need 300 years. So that's not possible to assess experimentally only using experiments. So then we built a machine learning model, the traditional one. This is like example of the result is a classification. And based on the prediction model from this machine learning, of course, we need the training data. So we needed quite a long time to collect the training data. But once we have the training data, we did the training. It only takes about maybe like 1 month. And then using this model, and this model recommend the best structures for these 3 metals of our interest. For platinum, it's really useful for catalyst. Lithium, of course, for battery, and also neodymium is the main component of strong magnet. So based on this recommendation from machine learning, then we evaluated it in the lab. So instead of, wait, sorry, there's some trouble.
Yeah, we have a little bit technical problem. Is it okay now? Okay.
Okay.
Sorry.
Yeah, sorry about that. So then we evaluated experimentally only for these 3 chemicals. So if we already screened these candidates, then experimentally evaluated this one, and the result was really promising. So this one was predicted to be selective for platinum, and yeah, it's very selective for platinum. and this one is for neodymium, and this one is for lithium. Of course, it's not perfect, but it's very useful. And then I had another idea. What if instead of just directly combine machine learning and experiment, we also combine it with some rules of thermodynamic rules, because machine learning at the time doesn't understand the rule of physics. So we combine it with thermodynamics and also some established simulation, like like DFT, molecular dynamic, and something like that. And then in this case, the context is to assess the formation of new chemicals. So we built machine learning model to predict the basic physical properties of a new chemical and build the regression model here. It's very standard, very simple model actually. And then we integrate the result to some thermodynamics equation, thermodynamic principle. And by combining this, combining machine learning and thermodynamics, we were able to predict the formation of 3,000 chemicals. So again, let's say if you are a really genius student, and you only need 1 year to evaluate one new chemical. So if we are going to screen 3,000 chemicals, then we need 3,000 years. But in using this useful technology, then we can speed up this process. Of course, we need to be aware there is some error. We need to check. The machine learning can make an error. We need to check it, but it's very useful to do large-scale screening instead of just relying on our intuition as a human. All right, so now we have this technology called generative AI. So the title of my presentation is about generative AI. So I will spend the rest of my presentation to talk about this technology in a little bit detail. So I'm sure everyone here is aware of this new AI tool like ChatGPT from OpenAI, Gemini from Google, and also this one, DeepSeek from China. It's really a very smart AI as well. And so what is generative AI here? Because I want to explain what is generative AI. I just asked ChatGPT to explain to me what is generative AI. And it explains to me really beautifully. So basically, it's an AI that can create new content. So like images, text, music, or even videos. And the model or the engine behind this type of AI, we call it as a large language model, LLM. And because we train it using a massive amount of text, then we can have a very realistic conversation with it, as shown in this example. So then we have this very straightforward idea, actually. What if instead of using just a random text, we use molecular structures as the training data for our large language model? What we'll get from there? Maybe we can ask the AI to generate something from us. And of course, we need to be focused for as a proof of concept. In this case, because I'm quite familiar with ionic liquids, and then we decided as the target molecule is ionic liquids. So it's a salt in the liquid state. It's very unique because usually salt is solid at room temperature, like your kitchen salt, sodium chloride. But this salt is liquid at room temperature, and this can consist various types of cations as well as anions. And many reports have been indicated that this can be used for CO2 capture, either as a liquid phase, a solid composite, or as a membrane technology. So it's many potential applications of these unique chemicals. But the problem working with ionic liquid is the chemical space is very big. So let's say this is the entire chemical space, and this is just for illustration only, not to scale. And this is the chemical space of ionic liquids. But actually what we can explore in the lab is, again, it's very limited. So it will take us forever to explore the entire chemical space of ionic liquids using experiment. or using first principle calculation, it also takes a very long time. And again, this is just to summarize the story. So remember that in my PhD, I did 3 years for only study one chemical. And then in my postdoc, then we were able to explore more than 100 new chemicals using the power of prediction from machine learning. And now using generative AI, we can explore more than 10,000 new chemicals in a very reasonable time. And how to do it. So this is how we train the model. So it's a little bit details here. So first of all, we need to collect the data sets. In this case, the data 0 is the chemical structures of our target molecule. And then data 1 is also the chemical structure, but labeled with the properties. In this case, because our target is for CO2 capture, then we have the CO2 solubility value for these ionic liquids. And we don't want our chemical to be toxic, so we also collect data related to toxicity. And then for our chemical notation, we decided to use, we call it as SMILES. So if you have these chemical structures, this is the SMILES representation. And for the basic of our model, we use GPT-2 because it's open source. So GPT-3 and GPT-4 are no longer open source, but we can still access the source code of GPT-2, so we can modify it, we can fine-tune it. And then for our prediction model, we use SMILES. I will explain what is SMILES in the next few slides. And this is how we did the training. So you use data 0, this one, and this one is ionic liquid structures, chemical structures. And we fine-tune GPT-2 using this data to be an AI that expert in ionic liquids. And we call it, this is just a name, but we call it as GPT-IL. And then we did training to SMILES. This is for prediction model, because this one, we cannot predict something using this model. So we train SMILES using data 1 to get a CO2 solubility predictor, and then using data 2 to get a toxicity predictor. And then we did we push the quality of our model using a loop of training. So it's like the model are helping each other to be better and better for generating new chemical structures. Well, again, this is quite details. This is how we process SMILES for language model. But yeah, the idea is very simple. So to train a generative model, we need quite a large of data, but actually 3,000 is very small for language model. So we did a data augmentation by permuting the atom order in the chemical representation. So from 3,000, by doing augmentation, we can get 10,000 to 30,000, so just improving the number of our data set. And we did tokenization using GPT tokenizer. Basically, it's to convert this string, we call it a string, this character into a number that can be understood by the machine. And the name of this number is, we call it as a tensor. And this is the result of the training. So if you have this learning curve that looks like this, when the loss function is gradually decreased to around 0, then the learning is success and it's really effective learning. And when we see the test loss distribution, it's revolved around 0.1. So the closer the value to 0, it's meaning the model is very effective to generate something that realistic. And in this case, the model was able to generate the next token, the next character in the sequence. And it means the model can understand what is the next atom in the next character that we give to the model. And again, after we train the model, then we generate, we design about 5,000 new ionic liquid structures. So this was not designed by a human. This was designed by our AI model. And this is just a few examples. And as a researcher that have been working in the field of ionic liquids for quite a long time, these structures looked very compelling to me. And then we evaluated the quality of the generated structures using some kind of matrix. This is we call it Tanimoto similarity. So if the value is small, it means the chemicals are very diverse, meaning it's not just generating one type of chemical, but very diverse structures. And this is the two-dimensional projection of illustrating the diversity of the chemical that was generated by our model. And it shows quite diverse chemical structures. So this is good. And then what we generate, we didn't have any idea about the properties because it's random generation. Is it really good for CO2 capture? Is it toxic? We don't know. So we need to make a prediction model. And in this case, we use a SmileSex. So SmileSex is a machine learning tool specifically designed for chemical structures. And it's based on language model as well. So if you are interested or you are familiar with deep learning, this is the pipeline of the model, and this is the neural architecture. The source code is available on GitHub, and it was developed by one of our collaborators at NIMS, National Institute for Material Science. It's located in Tsukuba. It's 2 hours from Tokyo. And then we train this model using data 1 to get the CO2 solubility predictor. And then using data 2, we can get the toxicity predictor in the form of log EC50. It's basically just a number to predict the level of toxicity of the chemical. And then using this trained model, we can compare the quality of the training data to the generated one. And it looks, the property distribution looks quite similar. So we can, in this case, we can manipulate the properties of the generated if we do something to the model. And then using our prediction model, we can make kind of a ranking. So we have 5,000 of new chemicals. So which one is good? Which one is not good for CO2 capture? So we make some kind of a ranking as illustrated here. If we pick up any structure from this green area, it would have a high CO2 solubility with low ecotoxicity, which is what we want. And if we pick something from the red area, it's not really good. So it has a very low CO2 solubility and very high ecotoxicity. So we want to avoid the chemicals that are in this red area, and we want to design something in this green area. And of course, because this is a new method, remember, machine learning can make an error. So we need to verify or at least compare it with more established method. So in this case, we double check it with simulation, with established simulation method, like density functional theory and also Cosmos simulations. And there are a lot of details here, but the main point is the trend, this ranking that was observed by our model is in agreement with the ranking that was calculated using the more established techniques. So we can trust our model. And then in the next step, we push the quality of our model by doing a training loop. So here, we only had about 3,000 of training data. Then we trained the GPT-2 model to generate this number of new ionic liquid structures. And because this is new structures, then we can use the prediction model to make a ranking, like I shown before. And we took the 50% of the top ionic liquid structures and then added to the training data. So now it's more than 5,000. It's about 6,000. And then we retrained our model, generated another set of ionic liquids. We took another 50% of the top generated structure, added to the training data, retrained our model, generated another set. We took another 50%, and again and again and again. It's a loop of training. It's an iterative process. And as shown here, by the 10th cycle, we already exploring more than 50,000 of new ionic liquid structures. And again, if you need 1 year to explore one chemical or to assess one chemical structures, here you need 50,000 years to explore this number of chemical space, but using generative AI, we can explore the very reasonable time. It's less than a year after we gather the training data. So of course, the hardest part is to collect the training data. Training the model is not that hard, actually. Okay, thank you. And then this is example of the generated structure. It's look really compelling, and something happened at the cycle 5, so we are still investigating it, so it's still ongoing. And then we evaluated the performance of the generated ionic liquids using some kind of score, and we can see here that the quality of the generated chemical structure was getting better and better as the training loop progressed, at least until cycle 4. And we also did some synthetic accessibility measurement. So it's a similar score between the training data and the generated data. So it means we can synthesize the generated structures because somebody else have been synthesizing the training data. So, and because it has similar score, we can also synthesize the generated structures. And now it's time to bring this finding into the lab because, again, I'm an experimental chemist. So I would be very happy if we can really test it in the lab, so not just a computational finding. And we have a stock of more than 1,000 ionic liquids that potentially very good for CO2 capture. And now it's still ongoing. We are collaborating with a group that expert in chemical synthesis and one group that expert in CO2 capture. We hope we can see the experimental result very soon. While waiting, because synthesis is never easy, so we need to wait for a while. And so we did some kind of alternative approach. So we did similarity search to the available ionic liquid in the market that has very high similar structures to what we generated using our model. And we found this one with a similarity score about 87% to our generated structures. And then we evaluated this one for CO2 absorption capacity, and it's really high. So, but this is not the real chemical that we generated. So we are still waiting the performance of the real chemical that are generated by our AI. And we hope that it will be higher than this one. So, all right. So that was just one example of where we can use generative AI to design new chemical. And besides ionic liquid and CO2 capture, we are also working on generative AI for designing new crystal structure for battery and also new molecule for improving the performance of solar cell. Now everything is ongoing. And I'd like to conclude my talk just to share, maybe it's my thought, what's gonna happen in the future. So I believe in the future, chemical space exploration will be done mostly by AI. And then we will do some simulation to evaluate what have been generated by the AI. And then in the lab, we just do some experiment, very little experiment to something that has been curated by our AI and our simulation. And even the experiments will be carried out by a robot maybe. And maybe in the future, what we need is someone that can supervise, maybe chemists or material scientists that can supervise all of this process. Okay, so just to close this presentation, I'd like to express my gratitude for this funding agency, so Japan Society for the Promotion of Science, JSPS, and Data Science Center in Kyushu University, WPI Eisner Center for Energy System Design, and also NIMS, National Institute for Material Science, for our very close collaboration with Professor Lambert. Okay, that would be all. If you have any question or comment, I would be very happy to discuss. Thank you very much.
Thank you, Professor Adroit Fajar. So I think the audiences also would like to hear more, but before that, we have another keynote speakers here, Professor Anneli Petersans. So since she was a leading researcher at the Laboratory of Study and Research on Wood Material, she will deliver the presentation material which entitled Wood Torrefaction, Production of Sustainable Material and Energy. Yeah. So you will have around 25 minutes.
Yeah, I try to.
The floor is yours.
Yes. So thank you so much for your kind introduction, and thank you for inviting me to share with you our research activity in France. So yeah, this research is teamwork from several partners, and I just mentioned some of them here. This is the partners of our team, our research team. So in this collaboration, we have the knowledge in France about the biomass thermal degradation, and the contribution of another Asian country from Taiwan. They help us to be more efficient with understanding and research about the biomass pyrolysis for energy production, and American team about the chemical biopolymers to know what happened in the lignocellulosic polymers and to be more efficient when we model the processes. And recently, researcher from BRIN Research Center help us to create a new axis using the machine learning and artificial intelligence to go deeper in the understanding of the processes and in the prediction. So now our University of Lorraine and BRIN apply for a memorandum of understanding. So I really hope in the near future we can collaborate together. So I will shortly present the University of Lorraine, the wood heat treatment in our lab, and our approach, the main finding, and I'll finish with summary for future work. So the University of Lorraine is situated in the heart of Europe. This is the region of Lorraine, here, near to the Paris, only 1.5 hours with the fast train. This university had been created in 1572. He grows with the years, and there were some troubles during the wars, etc. And in 2012, all the universities, the 4 universities with the engineer school, with the faculties, merged to form the University of Lorraine, which is a very big university. We have more than 60,000 students, 62 exactly thousand students, and more than 20% currently of them are international students. So I'll go fast. In this university, we have all the education topics like science and technology, graduated or undergraduate technology and engineer school, health, pharmacy, odontology, sport, law, economy, management, innovation, human sciences, art, literature, etc. These education and research topics are grouped in what we say the scientific poles, scientific areas, and there is 10 scientific poles in our university, and this pole group the different labs according to the topic in 8 doctoral schools. So doctoral schools are especially for PhD students and research. So the ambition of our university is to build a multidisciplinary technological model for education and research, increase the international visibility, reinforce the interdisciplinarity connection, increase the number of PhD, develop economic partnership, increase the number of international education programs, reinforce the scientific attractivity of our university. I go fast. So just to show you, our university is here, and the main center are in Metz in the north, in Nancy, and our team is situated, the last star here, in Épinal. So just a couple of pictures of Nancy with the beautiful square of Stanislas, some picture of Metz on the north. There is a very important student city with education and dorms, all the facilities for students. And we are in a smaller city, Épinal, very close to the city center, close to the river, and it's very pleasant to live and work there. So what about our lab? The Laboratory of Research Study of Wood Material. In our lab, we are interested from wood. When the tree is cut, it's called wood, and we leave the forest. So in our lab, we have all the multidisciplinary research like chemistry, mechanics, chemical engineering, biology. And here, the main location are Nancy and Épinal, but there is some other small teams all around the region. We have over than 40 academics and around 40 younger research, like PhD research, invited researcher, and postdoctoral academics. So the scientific skill interesting from the molecule, the smaller scale of the wood, you can extract some interesting molecules for antioxidant, for pharmacology, for health, for food also, to the one way to build some new material responsible for environment, wood structure, or you can use the wood for produce energy. So this lab is an interface between the academic research and the wood industry throughout some technology transfer center. Now I go to the development of wood heat treatment in the lab and the activity of our team. Nowadays, I'll just before talk about the production of sustainable wood material. The ambition is to substitute some materials like plastics or concretes producing CO2 emission with wood materials more environmentally friendly. But you cannot use wood directly in outdoor conditions, even for structures or building as for storage for energy, because of its shortcomings. One of them is the low durability. Wood is attacked from fungi. So when attacked from fungi, it's strongly degraded. Also, wood has a low dimensional stability, and it is not good when it is used for construction or furniture. And this is due to the hygroscopic character of the wood. So it is necessary to have preservation processes to use the wood. And last decades, the preservation processes using the chemical products are forbidden in Europe. So we need to obtain some new processes to protect the environment. And one of them is the heat treatment. The heat treatment means that you will keep the wood in hot atmosphere between 180 and 240 degrees in inner atmosphere to avoid the presence of oxygen and to avoid the combustion of the material. And to produce material, this process is led with very, very low heating rate between 0.2 to 1 degree per minute. And to the isothermal hot temperature plate, you have to keep the material between 8 and 12 hours. So it is used to produce material for building or for furniture. The industrial processes start very early. in 1910, and they still under the development. And here you can see some European industrial processes to produce wood for construction and furniture. In our lab, we start to interested about the wood heat treatment in 93, and we develop more and more research approaches to know more about this heat treatment. So just to situate, you have the direct combustion when the biomass thermal conversion is used under oxygen. And our activity is situated here. Torrefaction is for lower temperature and slow pyrolysis processes to produce new material or like pre-treatment for future pyrolysis or gasification processes. So you can use this material, but after end of life, because it is free from chemicals, you can use it for energy production. So it is interesting for the life cycle. So this is some industrial processes. One of them is the convective oven here, where the hot area, the hot media is the hot gases. So in the industry, they use it smoke or superheated steam, for heat transfer by convection. And the other process are the conductive oven, where wood is in sandwiches between hot plates, and extracting the air from the reactor. We work with very low pressure, around 200 hPa, to produce the wood, the heated wood. But even if this technology are developed, you see, for years, from 1910, they are not still well mastered. And sometimes you sell the boards, and some of them submit have some deformation or are attacked from fungi. So consumer is not happy, and there is some waste, and company lost around 40% of the production. So it is enormous. It is due to improve the processes. This is our interest. So to know how to improve the processes, to make the prediction for industry, we need to identify a control parameter. How we can to lead the process, and when we can say that this wood is good for uses in outdoor conditions. We need to know more about the behavior of the wood species, because in French forest and European forest, we have many wood species, hardwood, softwood, and we observe that these wood species behave very differently. The conditions to treat, the severity, temperature, and duration can vary over than 30%. It is not enormous for industry. So we need to know about the behavior of the species, the composition of the species, and to have some recommendation for industrial. We will try to build some numerical tool to help industrial to make decision. And obviously for us, it is important to understand fundamentally what happened in the wood and to valorize by publication. Oh. I have a trouble. It's okay. So our experimental approach very rapidly. It is a new approach, and I think this is very different from what we see in the literature. We made the choice to work in semi-industrial conditions. We have an oven here and a reactor. Oh, I'm sorry. We have a reactor which can work with big boards with industrial conditions. You see, you have 60 centimeters of length, 70 centimeters width, and 2.2 centimeters. It is really industrial board. So we can put 2 kilograms of material inside. And it is important because in the rest of the world, many researchers work with powders. However, powders modify the structure of the wood. You know, the porosity, the anisotropic character. So it is not representative to what happened really in the industry. So in this reactor, we can work with several inner atmosphere, vacuum, nitrogen, superheated stream. So to reproduce what happened in the industry. And we will characterize the wood before and after treatment with different techniques to know more about what happened in the polymers using fiber analysis, how the different polymers are degraded. Proximate analysis, it's important for the kinetic determination, but also for future characterization as for pyrolysis or gasification. Crystallinity and functional group to know more about the kinetics. Colorimetry to try to identify some control parameters, and TGA to control the powder behavior and compare with boards, and also like indirect methods to know about the kinetic of the parameters, the kinetic of the models. So here I show you some of the experiments about the treatment conditions. Here you have seen the how the process are lit. Here you have the temperature of the oven. So we have a first plate, like an industry, at 103 degrees, this is the standard, till master stabilization. After, we have a plate of 170 degrees. In industry, is used to have a homogeneity of the temperature in all the boards and to avoid crack of the process, because you can start to release some molecules and provoke some cracking. And after, you grow with low heating rate to the treatment temperature here, and we use it several treatment temperature. You make connection with the color, and there is an obvious relation between the degradation and the color. However, it is very difficult for industrial to follow the color to stop or not the process. And another control parameter I'll show you here, this is really funding from our lab. We make connection between the mass loss due to the thermal degradation and the mass loss due to the fungi attack. For the fungi attack, we took small samples of the treated and untreated wood. We put in culture with the fungi, and we keep in conditions favorable for fungi in 20 degrees and 70% of relative humidity for 16 weeks. And after, you take the sample, you remove the fungi, and you measure the mass loss due to the fungi attack. So you can see that if the degradation due to the thermal degradation is not really important, fungi attacks the wood. But for degradation between 8 and 14% of thermal degradation, your durability is perfect. So this is the proposition of control parameter to know the quality of the treated woods. And this is the main polymer, so I try to go faster. What happened during the treatment? So we identify several stages. First of them is to 100 degree, this is just the moisture remove. The second stage in 170 degrees, you have the extractive remove, and polymers are not degraded yet. Polymers that wood lignocellulosic polymers start to degrade at 180 degrees. And here you have the third stage, this is the thermal degradation. Okay, and the last one is the slight carbonization. And we observe that the polymers here with the DTG, you can observe the representative peak of hemicelluloses, celluloses, and lignin. So you can see that hemicelluloses are almost degraded, celluloses is strongly degraded, and lignins remain in the material. So we try to explain what happened in the material to explain this good durability. First hypothesis was that during the degradation, some toxic molecules are produced, and these toxic molecules stop the fungi attack. So we extract molecules from heat-treated wood, and we make impregnation for raw wood. However, this wood has been attacked by fungi. Thus, this hypothesis was not validated. The second one is the hydrophobic character, because treated wood has a very good hydrophobic character. However, oven-dried wood is hydrophobic, but it's attacked from fungi. So second hypothesis is not good also. The third one is the disappearance of the nutriments, because hemicelluloses and celluloses are degraded. However, in the literature you can find, and there is fungi attacking the lignin. So this hypothesis is not validated also. Recently, last year, we can observe that the small molecule produced from the degradation of hemicelluloses react with the network of the lignin and modify the lignin structure. Then fungi come to the wood, cannot recognize the nutriments, and that they're not attacked. For the recommendation for industrial, so industrial cannot follow the mass during the transformation. So we need to obtain some numerical tool to make the prediction, to make recommendation. We tried several models. However, what happened in the wood during the torrefaction is very complicated because of the variability of the wood. Wood composition is very variable between one species to other, between the tree growing in same species in different forests, and even in the same tree, we have different composition of the wood. So having exactly the reaction is not realistic. Then we tried several models. We adopt a simplified model, very used in the literature, the de Blasi model, where wood is accepted to be a homogeneous raw material, one composition, degrading from first reaction to an intermediate and releasing volatiles, and after degrading to the final intermediate and releasing other volatiles. And all the reactions of degradation and formation are modeled by first order reaction. I know this is not realistic, however, it works. And we adjust the parameters of the model using the experimental curves. So just here, I show you some results. This is the result with all the treatment intensity with the same set of parameters. So if you have one oven with one set of parameters, you can model very good the process. So we can make recommendation for industrial, but we need to study all the usage from the industrial spaces. So I go fast. Now we talk about the role of the potassium. It is known from the literature that potassium acts like catalyst for the process. So the idea is to optimize the process to save energy and time for industrials. So if the wood is used for energy, this is the pretreatment process. The same torrefaction process can be used like pretreatment process. The difference is that to use material, your process the temperature will grow very slowly to protect the mechanical properties. If you wanna grind the material, so you will let the process very fast, you will make many cracks and bad mechanical properties, so easy to grind. And for this, so this is the torrefaction we talk about. And now we will be interested about the catalytic torrefaction, and especially with potassium. Why potassium? Because potassium is naturally present in the woody biomass. It is nutrient for the biomass. So you have some biomasses rich of potassium. And the idea was to select the biomass before the treatment. So you need to use some knowledges from silviculture. the methods, so we tried, however, we cannot scale really the potassium of the presence of the potassium, and you know, the lignocellulosic components are very different. So we adopt the usually impregnation method, but always with the big samples, with boards. So we impregnate the wood in this kind of device using vacuum and pressure cycles. And we are looking for the update of the impregnation. We impregnate with several concentration of the solution, and you use it, the most frequently used it in the literature, potassium carbonate. So the first figure here was close to the material production. So you can see that the presence of the potassium has not really influence. So if you make impregnation, we will not improve the torrefaction for material production. However, we lead the process very long time. We know that have 20% of degradation is okay, but we lead the process long time because we use it more information for the kinetic parameters identification. And then we observe this curious point where the curves, you have an inversion. Impregnated sample degrade less than the not impregnated one. Then it is useful for energy production. We lead the treatment to higher temperature, to 300 degrees. And here we can observe an obvious influence of the potassium. When the potassium integration is important, the degradation is faster. And however, we have the same inversion point here, and we make this treatment for several temperatures, and this point is observed always for the same level of degradation. So we start to understand what happened in the wood. So we made experiments. We make the choice of the beechwood very abundant in the French forest, especially in our Lorraine forest. And the composition of the beechwood was analyzed. We took some pure materials like of cellulose, lignin, and xylon for the celluloses, and we simulate the composition of the beechwood. We make impregnation with the simple method, and then we make the same torrefaction process, but in TGA. We know that the structure is not kept in the mind. So here we can observe what happened with the different polymers. You can see that for celluloses, in the beginning, the degradation is accelerated, but later it's like an inhibition process. For celluloses, it's very obvious. The degradation is really accelerated, and there you have some inhibition. So it can explain this inversion point. For lignin is very thermally stable, so there is not really an influence. Yes, I go faster. Okay, go faster just for the main result. Okay. So we would like to analyze, because it's well known that when wood is dried, it's very difficult to impregnate. It was observed on some other applications. And we try to understand what happened, what can explain this acceleration of the reactions. So we took some samples from the surface and some samples for the core, and we analyzed with ICPAES what is the composition, what is the level of the presence of potassium in this part. So we have a raw wood. We use it a washed wood because we thought that we use some water solution. So maybe one of the naturally present potassium can go to the solution. And after we analyze with different concentration impregnation. So you can see here that between the washed and raw wood, there is not really difference. you can see some difference, but this difference is to the level to the variability of the wood. Here, you can see that when the concentration increases, the level of the potassium presence increases on the surface, but not in the core. There is not really modification in the core of the presence of the potassium. So we make the torrefaction in this reactor, and after we analyze what happened with FTI air analysis and some other analysis. So you can see here the raw sample, the treated impregnated sample for so only 5 minutes degradation, and for 60 minutes degradation. So we can observe for all the curves, impregnated or no, that the core is more degraded. Here you can see some representative functional groups, and you can see for all samples that core is more degraded than the surface. That's why it's important to highlight that the degradation reaction of the wood are exothermic. So the presence of the potassium cannot explain all the degradation acceleration. The presence of the potassium of the surface obviously accelerate, we saw that, the degradation, but maybe it increases the heat released from the degradation reaction. And this heat goes to the center of the sample, accelerating the degradation of polymers. And in the center, you cannot release the heat and the produced molecules. And some of the molecules, it's well known that, for example, the acetic acid or furfural produced from the degradation of hemicelluloses accelerate their catalytic action on the reaction. So the presence of the impregnation process is energy consuming. So you can maybe figure out that you can make pulverization on the surface just to optimize the process. So sorry for being longer. I'll stop here. Oh, next. Oh. So next figure are more deeper chemical analysis to show this more deeper core degradation. And thank you for your attention.
Yeah, thank you very much, Professor Anneli. It's really thoughtful presentation. I think both of you can share this common background. You come from a long history or long experience for the experiments. Then you might face the same challenge, how to scale up and how to bring this kind of technology into best practice. Like you mentioned about the impregnated problem, biomass things, and Professor Adrit also the generative AI in best practice industrial application, especially in molecular design. So before I would like to hear your response, but before that, I would like to invite one of the participants from the offline and one participant in online, right? So is there any question? But before that, please clearly mention your name and your institution. Thank you.
Okay. Thank you for the opportunity. Good morning, everyone. Good morning, professors and friends here. I would like to introduce myself. My name is Yedid. I'm from ITS Surabaya, Institut Teknologi 10 November Surabaya. So the question is to Professor Anneli from University of Lorraine. Is it correct? Yeah, I'm sorry for the if I'm wrong for the pronunciation. Because this is the question, because we are working on the PVC board, and then we are working with the wood. So we have a common how to say a similar condition, because we have to heat the wood so the wood can be, how to say, bent and not crack. The question is, because this is the not Hollywood or just this is just pure wood like that. So the question is, because we have several times we're not using that kind of advanced technology. We are using the traditional oven, so there is no temperature. And then okay, we can add the temperature gauge, but yeah, mostly we not use the temperature. But the problem is there is too many cracks when we are doing the bending of the wood. I think they are also professional, but the problem is on the heat. So the question is, do you have any suggestion of the heat? For example, if I want to heat the wood that have 25 centimeter of thickness and a 15 centimeter of thickness, and we have like the length of the wood is like 4 to 6 meters, like that. Thank you so much, Professor.
Thank you for your question. Well, we observe that if the heating rate is very slow, and in our experiments, to preserve the mechanical properties, because as I didn't talk about, but we measured also the degradation, the alteration of the mechanical properties. So if your heating rate is very slow, we use 0.2 degree per minute.
Okay.
So for our European spaces, we can reach a good mechanical properties. But I insist for our European spaces. In the past, we had a partnership with the industry for instrument production, and there is an exotic wood, and this wood cracks even during the drying conditions. So some of the wood is very difficult to treat, because some of the wood are very rich with the extractives, and when the extractives leave the structure, they can provoke some cracking.
So the suggestion
What is your wood species?
It's like pine wood, I think.
Yeah, I don't know.
Yeah. How to say
Pine. Oh,
Maybe
pine wood.
Yeah, pine wood.
Yeah.
Pine
Pine wood is very rich with extractive. But however, we have some experiments with pine wood is very abundant in our forest.
Okay.
So for us, the problem now is not the cracking, but it's more the tar release during the degradation. It's very rich of extractive. So the oven is awful up.
Okay. So the suggestion is like changing the type.
Changing the
Okay.
the heating rate.
Okay,
right,
heating
right.
rate. Okay. Thank
And
you.
what is your temperature level of the degradation?
We are not sure because we are not measuring. But after this, we will measure because we are building the traditional boat like that. So there is no measurement. But after this conference, I think I will suggest them to use the temperature gauge for how to say to make sure the temperature. So that's why I'm asking that.
You need to check also the temperature, because what we observed for our European species, in the literature you can find that torrefaction for wood production, for material production can go to 240 degrees. However, we observe that for temperature higher than 230 degrees, and 230 degrees are to be high. Mechanical properties are not very good.
Okay, thank you so much. That's really important. Thank you so much.
Thank you. Thank you for your question.
Thank you very much for your thoughtful, insightful and response. So, is there any news from the online? Not yet. So, Professor Edred, about the AI into molecular design. So, what is your opinion in a real application for something like maybe biomedical engineering?
Yeah, so and this field is still evolving and it's moving really fast, and it's really hard to predict what happened in the future, and because especially in the industrial area, because there is manufacturing, political things between the US and China, and many things happens. But for us in academia, what we are trying to build is a technology that can be verified by the others. So it's an open, so we always publish our code, our training data, so everybody can see, and we try to be as transparent as possible, so there will be no trust issue. And I think that's the important thing, is this is the technology that we can assess together. So yeah, I think that's the focus of our that's our concern for the future application of this technology.
Okay. So I guess this is the last of our first keynote session. So before we close, let me briefly summarize what the key important from our keynote perspective. So both of Professor Adroit Fajar and Professor Annelie Petersons highlighted the breakthrough innovation and technology that support sustainable communities. So together, their insight reflected the immense potential engineering technology to addressing global sustainability challenge. So lastly, I would like to thank both of our keynote speakers for their valuable contribution today. I also extend my gratitude to our audience for your engagement and insightful response. So why don't we give a big round of applause of our session today. Thank you very much, Professor Annelie, Professor Adroit. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Once again, please give applause for this very interesting session. And please remain on stage because as a symbol of our gratitude, we would like to present souvenirs from ICSEEA. And I would like to invite the head of Research Organization for Energy and Manufacture BRIN, Professor Chu Supriyadi Alinandar, to present the souvenirs to our keynote speakers and moderators. Please. Thank you very much for sharing with us your experience and your expertise. It was a very interesting and insightful presentation. And thank you for coming all the way to Indonesia, Yogyakarta, to be with us today. Please give applause to Professor Patricia. Thank you very much, sir, for sharing very interesting research about AI and for coming all the way from Japan. William is also from Indonesia, so it's a visit maybe very happy to welcome you, sir. Once again, please give applause to the speakers. And of course, to the moderator, please. Together already? Boleh bareng-bareng? Can we take group photo together once again, please? Special souvenirs from BRIN. Can we have a group photo together once again, please? host, showing the excitement and energy for having this 2-day conference. Okay, once again, please give big round of applause for the first plenary session. Please return to your seat. Thank you. Ladies and gentlemen, we will now take a short 10 minutes coffee break before we continue with the next keynote session. Please enjoy the refreshment available outside the ballroom and take this time to relax and network and visit the exhibition booths from Par Instruments and Hioki Electric Indonesia. And don't forget to take some pictures also at the exhibition booth. So it's 10:26 right now. So we come back here in this ballroom at 10:36. 10:36. Okay, please enjoy your break.
For more than 7 decades, PLN has carried out the state's mandate to electrify the whole Indonesian archipelago. PLN is entering a new chapter in its transformation, aiming to become not just a power and utility company, but also a technology company based on innovations. All of this is to improve service quality, strengthening the domestic industrial ecosystem, and increasing competitiveness in the global stage.
Research is our strength.
For more than 7 decades, PLN has carried out the state's mandate to electrify the whole Indonesian archipelago. PLN is entering a new chapter in its transformation, aiming to become not just a power and utility company, but also a technology company based on innovations. All of this is to improve service quality, strengthening the domestic industrial ecosystem, and increasing competitiveness in the global stage.
Ini waktunya akselerasi. Buat wujudin mimpi itu harus rame-rame.
Rame ini.
Yes! Mantap! Gak cuma sekedar wujudin mimpi, tapi ciptain inovasi. Kita berkolaborasi biar ngasih impact positif buat bangsa Indonesia. Ayo, wujudin swasembada energi dengan terus berakselerasi tanpa henti. Pertamina, energizing the acceleration, energizing you.
For more than
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA.
ICSEEA 2025 participants, we would like to invite you to come back to Boru because we will resume our agenda.
Through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs. Tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology practices and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Ladies and gentlemen, once again, we would like to invite everyone to come back to ballroom so that we can continue our next session. Tapi itu pintunya harusnya nggak apa-apa. Mau nggak mau. Namanya kenapa mau beruntung? ICCEA participants, welcome back. We hope you enjoyed the coffee and snacks and are feeling refreshed for our next session. Next, we have a presentation by Mr. Onodera Hitoshi from the Japan Automobile Standards Internationalization Center, Japan. This session will be chaired by Dr. Aam Muharam. He is the head of Research Center for Transportation Technology, BRIN. Now I would like to invite Dr. Aam Muharam and Mr. Onodera Hitoshi to the stage.
Okay, thank you, MC, for the introduction for us. Good morning, distinguished guests, college, and also participant and the keynote speaker. Welcome to this keynote session of the 12th International Conference on Sustainable Energy and Engineering and Application. So I will say that in a word, balancing technological process with ecological responsibility, the Euro 5 and Euro 6 standards stand as milestones. From Tokyo to Brazil, their applications are reshaping how we drive toward sustainability, and today we gain insight from a leader in this field. So today we delve into a critical topic, shaping the future of sustainable mobility, emission standards, and their technological implication. Euro 5 and Euro 6 regulation represent pivotal steps in reducing vehicular emissions globally and their application and transforming industries and policies alike. So we are honored to host a speaker from JASIC, Japan, an organization at the forefront of advancing automotive standards and environment solution. Thank you. So I would like to introduce our speaker today in this time. So Mr. Onodera Hitoshi, an experienced member of Pollution and Energy Subcommittee, JASIC, Japan Automobile Standard, and Japan Automotive Standard Internationalization Center, and also a member from senior engineer in Nissan Motor Corporation, right? And I see you also under the powertrain and EV engineering division. So it's very related to our topics today. And let me introduce about me also. I'm Muharam from the Research Center for Transportation Technology, National Research and Innovation Agency. So I will moderate this session, moderator. Let me, because I already introduced the speaker. Without further ado, please to the stage for what promises to be an enlightenment presentation. Mr. Hitoshi, the stage is yours.
Okay. Thank you. So good morning, everyone. I'm Hitoshi Onodera from JASIC, Japan Automobile Standard International Research Center. And in parallel, I'm working mainly in Nissan Motor Corporation to develop the after-treatment system development and also the emission certification section in Nissan. I have some experience to develop the after-treatment system for the clean diesel in the European market and Japanese market. So I would like to have some presentation about the Euro 5 and Euro 6 emission standards, also the challenge of the opportunities for biodiesel adoption. So before my presentation, in this presentation, 3 primary goals are set. First is to introduce and provide an overview of the Euro 5 and Euro 6 emission standard, their evolution and also reducing targets. And the second one is to educate the participants on the after-treatment technologies that support high concentration biofuel use in both gasoline and diesel engines. And the third one is to explore the challenge and the opportunities to using biofuels in achieving Euro 5 and Euro 6 compliance in Asia. So in this presentation, on the basis of these goals, I would like to have some presentation about on the 3 topics. In the overview of the Euro 5 and Euro 6 standards, I introduce focus on the Euro 5 and Euro 6 emission limit and the implementation regulations. And additionally, I introduce the emission test procedures on World Light Duty Vehicle Test Procedure called WLTP, and real driving emission test procedure called RDE. Then I briefly introduce the regulatory implications. And the second one is in the key after-treatment technologies, I introduced the 3 key technologies, 3-way catalyst, and particle filter, and selective catalytic reduction called SCR. Based on these after-treatment technologies, I introduced the general challenge for emission compliance in case of the biofuel application. The last in the challenge of the Euro 5 and Euro 6 compliance in Indonesia, I introduced some countermeasures and indications and the pathway to Euro 5 and Euro 6 emission regulations. So I'd like to start the topic 1, overview of the Euro 5 and Euro 6 standards. At first, I introduced the emission limit evolution for the petrol and diesel vehicles. So this slide shows the evolution of gas pollutants emission limit, carbon monoxide, and also the hydrocarbon and NOx for petrol passenger vehicles. The gas pollutant emission limit values were drastically decreased at Euro 4, this one. And the Euro 5 NOx emission limit was decreased a little, and the non-methane hydrocarbon emission limit was applied. All the emission limits are keeping the same value after the Euro 5. And however, emission limit test driving procedure was changed from the new European driving cycle, NEDC, to a worldwide harmonized WLTC from Euro 6C. The WLTC driving energy is much higher than the NEDC cycle because WLTC vehicle speed profile is transient profiles rather than the NEDC. So it means that even if the limit value are the same, the emission limit are stricter from Euro 6C impact. So let's check the particle emission limit to the next slide. Okay. So this slide shows the evolution of particle emission limit for a petrol passenger vehicle. In Euro 3 and Euro 4, the particle emission limits are not set for the petrol vehicles. And from Euro 5, the particle mass emission, PM limit was applied. Then particle number, PM emission limit was applied from Euro 6, only for gasoline direct injection called GDI engine vehicle. This one. As well as the gas pollutant emission, WLTC driving cycle was applied from Euro 6. And the RD test was started from Euro 6D. As I mentioned before, WLTC and RD test driving energy is higher than the NEDC. So PM and PN emission limit became stricter. For near future European emission regulation like a Euro 7, particle number emission target is going to be changed from PM23 to PM10. In addition, not only GDI engine, but also the port fuel injection engine, PFI, is eligible for the particle number emission compliance. So from the next slide, I introduce the evolution for diesel passenger vehicles. For the diesel passenger vehicle, hydrocarbon and NOx emission, indeed the NOx emission limit is decreased in each emission regulations. Okay, thank you. Like this, gradually decreased. In Euro 5, Euro 6 NOx emission limit was 84% down to Euro 3. Sorry, yes. So vehicle complied with Euro 6 generally introduced the NOx after treatment technology into the exhaust line. Particularly, NOx after treatment technology application was shifted to selective catalytic reduction, SCR, after the application of the WLTC and RDE, like this situation. The catalytic reduction, SCR, after that application, the next slide, I can show you the particle emission limits. Yes, for diesel passenger vehicle, particle mass emission limit was set out from Euro 3 before the petrol vehicle. In Euro 5, emission limit value was 19% decreased from Euro 3. This one. And so all diesel vehicles generally introduced the diesel particle filter, DPF. As well as petrol vehicle, particle number emission limit was set out from Euro 5B. This one. And from Euro 7, PN target is going to change to PN 10. So next slide, I introduce the annexes implementation regulations. So this slide shows the annexes of each emission regulations. Emission regulation annexes consist of emission type approval from type 1 and type 6, and onboard diagnosis and conformity production and in-service conformity. Also, fuel property is included. During the evolution of emission regulations, fuel property for ethanol, blended gasoline, and biodiesel implemented in Euro 5 and Euro 6B in the European market. This one. And the number of the annexes is increased as new emission regulation was applied in WLTC, RDE, and AES and EBES. This one. And the next slide, focusing on the type approval test. So that this table shows the matrix of the implementation of the type approval test in each emission regulations. Some part of the emission tests are mandatory for not only the type approval, but also the conformity production and the in-service conformity. And there are three key changes point in Euro 6. First point is driving cycle and the test procedure from NEDC to WLTC. And the second point is the emission durability provision. Durability mileage in Euro 6 was 2 times longer than the Euro 5. 18,000 kilometers to 160,000 kilometers durability. The last point is RDE was implemented after the Euro 6C. To summarize the outline of Euro 5 and Euro 6 emission standard, emission limit value was shifted stricter than the Euro 4 in the diesel vehicles. In parallel, the emission limit also substantially stricter due to the implementation of driving cycle to WLTC and RDE. And additionally, annexes of the emission regulation was increased. So these kinds of implementation were required to apply the new after-treatment technologies. So next topic, I introduce the outline of the WLTP and RDE briefly. So first, WLTP, I introduced some key points of the United Nations regulations number 154. So this slide shows the structure of UNR 154. WLTP test procedure have been making by the leading of the Europe and Japan in order to harmonize the emission test procedures. You can see that UNR 154 has 2 floor structures, level 1 and level 2. And in level 1 structure, there are 2 requirements called level 1A and level 1B. And in level 1A, driving cycle is required 4-phase WLTC. And level 1A test is applied in EU countries. and China and Korea. On one hand, level 1B is required three-phase WLTC test cycles. And level 1B test required in Japan and India. India is from 2027. So next slide, I introduce the definition of the WLTP driving cycles. So this slide shows the comparison of the concept between NEDC and the WLTP test cycles. In NEDC cycle emission test, there is no criteria to separate the test profile. It means that one driving cycle is utilized in all of vehicle category for passenger vehicles. On one hand, WLTC has some classes specified by power to mass ratio and maximum vehicle speed. It means that the driving profile is different from the vehicle specification. So I show the vehicle speed profile for each classes in the next slide. In WLTP, there are four driving cycles depending on the vehicle power to mass ratio and the maximum vehicle speed. Each driving cycle consists of four phases: low phase and medium phase and high phase and extra high phases. Also, contracting party can decide whether to adopt extra high phase or not, in accordance with their internal provisions. For instance, contracting party as Japan and India to adopt level 1B is not adopt extra high phases, only using the three phases. Because their maximum speed limit is the public road is not exceed the 100 kilometers per hour. Therefore, it is not necessary to adopt the phase which to drive over the 100 kilometers per hour. Next slide, let's check the facility to adopt WLTC and the future regulation. So this slide shows the example of the emission test laboratory. These kinds of composition are introducing by measurement facility manufacturers. They have been considering the mature facility components in accordance with the new and amendment regulations. Also, the vehicle specification would be changed like vehicle electrification. And so additional device and the facility is needed, which are different from the conventional internal combustion engine vehicle. So next slide shows the one of the facility for considering investigation, research, and development. The facility can simulate the real driving emission, driving condition in the laboratory to control the temperature, ambient pressure, and the gradient as slope. Also, in consideration of real driving emission test, the validation of measurement device to be necessary on the chassis dyno. In addition, some exhaust gas analyzers are installed to measure non-regulated pollutants like ammonia and N2O. To summarize, WLTP test consists of different levels considering the country's individual rules and conditions. And the test cycle is separated depending on the vehicle power to mass ratio and also the maximum speed. It is necessary to introduce or modify the test facility in accordance with the regulation and also the evolution of vehicle specification, like electrification. So next, I introduce the real driving emission test. So for the real driving emission test, there are two roles. first one is to check the conformity at the normal driving of use on the public road. It means to find high emitter vehicle. Another role is to detect the defeat devices in the actual vehicle usages. The figure shows the comparison between WLTP and the RDE. As I mentioned in the previous slide, WLTP test is conducted in the laboratory under constant conditions. On one hand, the RDE test is conducted in the real market conditions on the public road, basically. And the RD test trip data is distinguished with speed bin and have a data evaluation. Also, RDE test final emission is validated using the conformity factor. Next, I introduce the portable emission measurement system briefly. So this slide shows the roughly description of the portable emission measurement system called PEMS. PEMS is consisted of the exhaust gas analyzers, not only gas pollutant, but also the particle number, and the exhaust flow meter, and some devices to measure the GPS position, and also the environment condition. All of the devices are installed in the actual vehicle. Total weight is over the 100 kilogram. So that this is an example for installation of all of PEMS measurement devices using the light commercial vehicle. This vehicle has a big volume to install the measurement devices, so PEMS is installed inside the cabin, like this. But for considering the small vehicle, PEMS would be installed outside the vehicle in some cases. So next, I show the structure of the RD test. So this slide shows the structure of the RD test regulation, UNR number 168. This structure is similar to UNR 154 WLTP test procedures, also almost mirror structures. So WLTP emission test results are utilized to evaluate the RDE emission level. Therefore, compliance requirement is defined for two four-phase WLTC and three-phase WLTC individually. So next, I introduce the RDE test validity check. So this slide shows the process of the data evaluation in RDE test described UNR 168. In the RDE test, a lot of data evaluation are required, like this. The trip characteristics, and cumulative altitude gain, and driving dynamics, and also the trip dynamics here. For validate on the RD test, all of data evaluation have to meet the requirement. If one of the evaluation cannot meet the requirement, all of the RD test is invalid and the retest is required. So it is necessary to conduct RD test carefully to avoid the test invalid. So I introduced about the outline of RD test. Some countries already apply this test and will be introduced in next emission regulation. This table shows the comparison of the RD test condition in each countries. Like EU, China, Korea, Brazil, Australia, and Taiwan, and India, and Japan. For instance, as you can see, countries set out individual provisions aligned with each country environment conditions and so on, like this, in Brazil and in India. For instance, Brazil and India set the temperature condition higher than other countries, considering the coverage of annual temperature. Also, reference test cycle for data evaluation is used the original test cycle, FTP and MIDC, not using the WLTP. Of course, Japan has some individual provisions. This table shows the comparison of the some provision between EU and Japan. The key discrepancy is showing colored red. And the originality of provision in Japan is that RD test is conducted not only public road, but also the test track. Japan has their strict safety rules for the new type vehicle. Also, in some cases, RD test is invalid due to the traffic condition. Therefore, Japanese authority set out the individual property to avoid this kind of test risks. So far, I introduced the outline of the Euro 5 and Euro 6 emission regulations and WLTP and RDE emission test. So to close the topic one, I indicate their regulatory implications and the implementation strategies. But this is the general indication, not especially for Indonesia. So when we consider to set the new emission regulations or update the actual regulation, it is necessary some background and intention by government and authority. On the point of regulation, government and authority consider the air quality and climate change in the country. Of course, consider the health effect to the citizens. Showing the left figure show, battery electric vehicle is one of the ultimate contribution for the zero emission. It is necessary for ICE vehicle to make an effort to reduce their emissions using the useful technologies like electrification and carbon neutral fuels. On one hand, we have to consider the availability of the countermeasures. Of course, we can use the state-of-the-art technologies. However, vehicle cost will be increased, then reflect their vehicle price. Some countries are taking measures like tax incentives in order to introduce the clean vehicles in the market. To summarize, it is indicating that we have to consider the maturity of the political and technical measures. So I would like to shift the presentation to the next key topic, two after treatment technologies. So in this topic, I introduced key after treatment technologies, three-way catalyst, and the particle filters, and the selective catalytic reduction. So this slide shows the evolution of the catalyst system. For petrol vehicle, three-way catalyst, TWC, is mainly utilized. Sorry. Like this. And after the Euro 6C, emission reduction was required in WLTP test cycle. Additional TWC is installed on underfloor position for some vehicles. And also by means of the introduction of RDE and AES-BES provision, some vehicles are equipped with the new function, particle filter from Euro 6E. For diesel vehicles, various functions are introduced in each emission regulations. From Euro 5, almost vehicles were equipped with particle filter for meeting the PM and PN emission limit. In Euro 6, the new function, NOx reduction technologies are introduced. Indeed, Euro 6D, some vehicles are utilized the state-of-the-art after-treatment systems of catalyst function integration and additional NOx reduction function, like here. Well, from next slide, I introduce the three-way catalyst briefly using the few slides. So this slide shows the schematic image of the TWC and the reaction scheme. Showing the left figure, like this, three-way catalyst is coated on the wall of the honeycomb substrate, like this. The exhaust gas pollutants contact the catalyst and convert the non-pollutant species like CO2 and nitrogen. This figure shows the reaction scheme on the three-way catalyst. On this catalyst surface, oxidation reaction and hydrocarbon and carbon monoxide and reduction reaction of the nitrogen oxide are occurred simultaneously in appearance. Next slide, I introduce the combination of the reaction and the engine control. So in order to get the three-way catalyst conversion performance, air-fuel ratio is controlled in the engine system. Exhaust gas sensor is installed to the exhaust line. The output signal is entered to the engine control unit, and then air-fuel ratio, A by F, is calculated with the combination of other sensors. A by F is controlled the cyclic operation, like this, between rich phase and lean phase. As I mentioned that the oxidation and the reduction reaction are occurred simultaneously. In the emission control of the engine system, in fact, oxidation and reduction reaction is occurred cyclically on the three-way catalyst surface, showing this right figure. By means of this kind of A by F control operation, the three-way catalyst can keep conversion performance, high conversion performance. As showing in the right figure, the reaction keeps high conversion performance in the specific coverage of the A by F ratio. Next, I introduce the particle filter. So this slide shows the shape of the function of the particle filter. The photograph shows the example of a particle filter. The filter has a honeycomb shape, but the cell has the plug showing this picture in order to accumulate the particle like this. Accumulated particle is bound with the regeneration operation. In the filter regeneration, there are two kinds of oxidation reactions called passive regeneration and active regeneration. Next slide, I introduce the two kinds of the functions, soot accumulation and soot oxidation. So this slide shows the soot accumulation and accumulation function. This is an example of the particle filter system. In the exhaust line, the pressure sensor is equipped to measure the differential pressure between the filter inlet and outlet. When particle loaded in the deep bed of the substrate wall inside, the differential pressure is increased so high. Then particle is loaded on the wall of the and generate the soot cake layer like this. Differential pressure gradually decreased. So in the particle filter control, the mass limit is set out in order to start the soot oxidation operation. So in the actual control, the differential pressure is achieved the criterion filter regeneration operation will be started. Next slide, I introduce the filter regeneration operation. So this slide shows the operation scheme for particle oxidation called filter regeneration. As shown in the left figure, when differential pressure achieved the limit value, engine control is changed to heat up the filter. And the filter temperature achieved the target, filter regeneration is started. But if soot oxidation reaction starts suddenly, the filter will be broken and melt due to the heat of the oxidation reaction. As an example, the filter temperature will reach maybe over 2000 degrees Celsius. To avoid this kind of filter broken, excess air is controlled in the engine operation, like this. The right figure shows the relationship of the filter temperature and the excess air ratio called lambda. During the filter regeneration operation, the filter temperature and the lambda is controlled in this coverage. So from next slide, I shifted to the introduction of the SCR technology. So before the introduction of SCR, I show the representative NOx reduction technologies in this slide. We have some major technologies, Linux trap and ammonia SCR and hydrocarbon SCR. These three NOx reduction technologies are introduced to meet the NOx emission regulations in the actual vehicle. And this graph shows the comparison of the NOx reduction performance. Ammonia SCR and the Linux trap has a high conversion performance, like this. On the other hand, hydrocarbon SCR performance is relatively lower than the other technologies. So in case of the stricter emissions, like a Euro 6 emission, that a high performance required. So Linux trap and SCR are mainly utilized generally. From the next slide, I briefly introduce the urea SCR system. So on the basis of the NOx reduction reaction in urea SCR, I show the two major ammonia SCR reaction schemes. One is using the copper zeolite catalyst. The another one is using the vanadium catalyst. These NOx reduction reaction schemes are complicated rather than the three-way catalyst. The common feature of these kinds of catalyst reaction, ammonia and NOx adsorb the active species, copper and vanadium on the catalyst. For urea SCR system, one of the key points is to generate ammonia from urea solution. So this slide shows the outline of the urea SCR reaction. Urea solution is dosed into the exhaust line. The urea has hydrolysis reaction to generate the ammonia with the heat of the and steam in the exhaust gas. The NOx and ammonia are adsorbed on the SCR catalyst. Then NOx is reduced to nitrogen by the standard SCR reaction and fast SCR reaction. So next slide, I introduce the urea decomposition. So this slide shows the mechanism of urea decomposition and generate crystalline. In general, urea solution is typically decomposed to ammonia and CO2 by hydrolysis decomposition. But some excess urea remaining in the exhaust line is concentrated and the urea crystal is generated. By means of this, the heat of the exhaust gas, urea is generated the some stable crystalline, burette and cyanuric acid, like this. Then accumulated in the exhaust line. These crystallines causes the big impact to engine operation, like power reduction and also the, in worst case, engine stall. So it is very important to control the urea dosing to avoid these kinds of risk. So next slide, I introduce the model case of the actual urea SCR system. So this is an example to representative urea SCR systems, especially for meeting the strict emission regulation. In the actual urea SCR system, a lot of devices like and sensors to be necessary. Moreover, urea dosing control unit is installed in the vehicle. And the dosing control unit is connected with the engine control unit via CAN protocol. So urea SCR system means the complicated rather than the other after treatment system. And this slide shows the representative example of the state-of-the-art urea SCR system. After Euro 6D emission regulations, real driving emission is required. As shown in this figure, the RDE driving condition is wider than the other driving cycles, like here. Also, the ambient conditions are also wider. So in order to meet the emission regulations in the wider test condition, additional SCR function to be necessary. To solve this problem, in the same space like light-duty vehicle, particle filter and SCR catalyst function were integrated in one filter substrate as an additional SCR function, like this. So next, I introduce the challenge of the after-treatment system technologies using biofuel briefly. In this topic, generally high concentration biofuels gives some impact for vehicle system. But in this presentation, I would like to focus on the impact to the exhaust gas emission. At first, I introduced the petrol vehicles. So might be, ethanol attack to the rubbers and the metal corrosion by water absorption and the engine stability and drivability at low temperature conditions. Additionally, ethanol gives a big impact to the evaporative emissions. Looking into the exhaust emission, there are some big impact using the high concentration ethanol fuel. However, we have some solutions technically to optimize the fuel properties and emission control. Actually, a specific vehicle applying E85 fuels is introduced in the Brazil market, and some countries set out the fuel standard for high concentration ethanol fuel to mitigate the emission risks. So next for the diesel vehicle. In the diesel fuel, the impact is different from the specification of biofuel. So in this presentation, I would like to focus about the impact by FAME and HEVO. So this slide shows the classification of the risk and for exhaust emission to use the FAME and HVO fuel, assuming the concentration over B5. The usage of high concentration biofuel gives the fuel specification. The risk of HVO is lower than the FAME because HVO specification is a little bit similar to the conventional diesel fuel. On one hand, FAME has the big impact to deposit and ash formation by the contents of the exhaust gas temperature due to the lower heating value of the fuel. So next, I show the challenge of the biofuel usage for meeting Euro 5 and Euro 6 in Indonesia. So this slide shows the classification of the issues and the countermeasures for usage the high concentration ethanol fuel. Of course, the best way is to get closer the high concentration fuel property to the conventional gasoline. But for considering to reduce the risks to usage of the after-treatment technologies, we can consider to modify the catalyst design and the A/F control strategies. On one hand, for diesel fuel, I recognize that some big risk is remaining. Part A, ash formation and accumulation due to the oil dilution and the biofuel components. And the part B, catalyst poisoning due to the metal components in the exhaust gas. And the part C and D decrease the catalyst conversion performance and the defective of particle filter regeneration is concerned due to the lower exhaust gas temperature. So I introduced these representative four risks using the several slides. So as a challenge of biofuel usage for Euro 5 and Euro 6, I would like to introduce the concerns and countermeasures focused on the biodiesel fuel. At first, I introduced the ash concerns. So generally, ash is formed by the metal oxide. And this slide shows the components of generating the ash in diesel engine. Metals are included in the oil, fuel, engine coolant, and the air. Almost part of ash is generated from the oil dilution. Also, some part of ash is generated by the biofuel trace. Next slide, I introduce the ash accumulation on the particle filter. So this slide shows the schematic image of the ash accumulation. Left picture shows the ash accumulation in the particle filter. The particle filter was cut to see the particle filter honeycomb cell. As you can see, large amount of the ash is accumulated at the end of the cell. As the ash is accumulated in the cell volume is decreased. It means that the effective volume which can load the suit is decreased. So this slide shows the physical property of the ash and the impact to suit loading by ash accumulation. Left chart shows the example of the change of the ash component by temperature. The red dot is the particle filter regeneration target temperature. The ash changed in the structure with the temperature and remaining in the particle filter over the filter regeneration temperature. It means that it is impossible to sublimate the ash by the filter regeneration once ash is accumulated. As shown in the right graph, the soot mass limit is decreased due to the ash accumulation. It means that the filter regeneration started at the lower soot loading, so it is important for a reasonable filter regeneration to avoid the possibility of ash formation and accumulation in the particle filter. So next slide, I introduce the catalyst poisoning. This slide shows the schematic image of the mechanism of the catalyst poisoning. Generally, catalyst is consisted of the active site material like precious metal, platinum, palladium, and rhodium, and support materials like metal oxide, aluminum oxide, and cerium oxide. Some metal oxide in the exhaust line, like silica and phosphorus oxide, is covered in the active site on the catalyst surface. Then catalyst conversion performance goes down and deactivated in the worst case. So it is possible to release this kind of oxide to increase the temperature. But in case that to use the biofuel, there is a risk of the incomplete to get the target temperature due to the lower heating value. Against these kinds of risks, I introduced the countermeasure in the next slide. So this slide shows the major countermeasure for the concern about the ash. The main countermeasure is to reduce the ash component. For oil and fuel, it is reasonable to make the specification standard. So in addition, oil manufacturers are introducing the ash-free and low ash oil in the market. On one hand, particle filter manufacturers modified the cell design to increase the effective volume of the cell. This is an example of the asymmetric cell structure of the particle filter. So next, I introduce about another concern due to the decrease of exhaust gas temperature. So generally, exhaust gas temperature affects the catalyst conversion performance. Moreover, decreased exhaust gas temperature affects the SCR system operation too. In the urea dosing operation, urea dosing is permitted above the exhaust gas temperature exceeding about 200 degrees Celsius. And considering the ammonia generation and the fast SCR reaction. In case the combination between the low-speed driving and usage the biofuel, it is important to keep the temperature target in the market use case. So next slide, I introduce another risk of the particle filter regeneration. So this slide shows the comparison of the exhaust gas temperature in two different fuel specifications. As you can see, in the same engine calibration, exhaust gas temperature is decreased and not achieve the regeneration target temperature when B20 fuel was utilized. In case that the filter regeneration is operated in the market driving, it has a risk defective of filter regeneration. It indicates that to be necessary to consider the reliable filter regeneration strategies to cover the market condition and also the customer usage. In the next slide, I introduce the countermeasures of this kind of matters. So this table shows the representative countermeasure. In the market sense of optimize, it makes sense to optimize the exhaust gas temperature in engine calibration. And on one hand, it is necessary to expand the coverage of the activation temperature. It means that it is important to optimize the catalyst position in the exhaust line for defective particle filter regeneration. It is important to get practical filter regeneration in the market. One of the best ways is to set optional filter regeneration strategies out of use case. So I can see the actual examples applied in the market. So this slide introduced the representative example of the diesel after treatment system by Volkswagen and Audi. In this after treatment system, SCR catalyst is moved to upstream the position by the integration of with the particle filter. And concretely, SCR catalyst wash coat make a catalyst layer on the surface of the filter wall. So these kinds of the modification are possible to expand the coverage of the urea dosing in the vehicle operation condition. And for defective of the filter regeneration, a unique regeneration strategy is installed in the vehicle for the specific market. This slide introducing the example of the optional manual particle filter regeneration operation. The vehicle manufacturers installed this kinds of the optional operation for low-speed driving market. For instance, there are a lot of diesel vehicles which are equipped with these kind of optional operation in Japanese market. So the customer can operate the filter regeneration without the request of the high-speed driving to get the regeneration temperature. So I briefly introduced the outline of the Euro 5 and Euro 6 emission standard. key after treatment technologies, and the risk of the challenge of the meeting emission with the biofuels. In order to summarize my presentation, I made the indication for the concept of the strategies to adopt in Indonesia. So at first, for the petrol vehicle, I suppose that the strategies for ethanol blended gasoline introduction strategy is not so different from the other countries. Also, some countries like Europe and Brazil apply the stricter emission limit using the E20 level. So it is mature for Indonesia to harmonize the strategies and align with the fuel property and standard. On one hand, it is different position for a biodiesel fuel. If not considering the actual emission regulation, Indonesia position is the top runner, only using the high biofuel usage. Because it is no need for Indonesia to consider the negative impact for engine reliability at lower temperature. Also, in current situation, other countries set out the stricter emission limit, don't have a direction of the high concentration biofuel. At one point, Europe made a high concentration biofuel standard available for Euro 6 vehicle in 2022. Like this. And the European standard might be EN 228. So it might be forcefully, I put the trend line like this. I'm not sure whether the trend line is feasible or not, but it might have some an opportunity to consider the possibility Euro 5 emission level to apply the Euro 6 technologies. So this slide, I changed the trend information from the emission regulation to after treatment technology viewpoint. So it is one of the good opportunity to investigate the emission level using diesel oxidation catalyst and particle filter and SCR and high concentration biofuels. So in order to summarize my indication, I clarified some candidates. I think it is a good opportunity to set the investigation program as a consortium scheme in Indonesia. And to finish my presentation, I just introduced the outline briefly for each topics using a lot of slides. I hope my information helps the consideration of the new mature emission standard in Indonesia. So thank you very much for your kind attention. Terima kasih. Thank you.
Thank you so much, Mr. Hitoshi, for your great presentation, and I think it's really deep and details, right? So I would not to stop the presentation because we wait for the last information that you deliver, and also this very insightful knowledge for us, since it's very related to our goals, right? For sustainable transportation, especially, and to bring the net zero emission to the world. So thank you so much. Now we go to the Q&A session. So I would like to also introduce in the left, Mr. Hitoshi is the interpreter or penerjemah, ya, the translator. So if you have a question, so Mr. Yonosan ya? Yonosan. Bahasa Indonesia ya? Ya. Mas ya, no lagi. This because it's a half Indonesian in Japan, right? Quarter. So if you have a question in Indonesia, don't worry. We have a translator, so he can translate to Japan or English. Itu Sisan. Now I will open to the floor, maybe offline first and then online. So please raise your hand if you have a question. I believe there is many questions here because it's related to our research activity. We have a standard, we have manufacturers, we have the energies, and any else, and the environment, so many. So please raise your hand. Biasanya pas Fajar ini. Ya. Boleh. Bahasa Indonesia boleh, silakan. We will speak in bahasa.
Thank you for your time. Izin pakai bahasa Indonesia, Pak. Gimana ya? Jadi Indonesia kan memang saat ini memang menuju ke penggunaan B20. Nah, we towards to the biodiesel fuel. Kita menuju B20. Lalu kita tahu bahwa teknologi-teknologi yang ada di sekarang ini kan memang masih Euro 4 di kami. Nah, sebenarnya persiapan secara teknologinya itu di after treatment misalkan khususnya itu memang cukup besarkah apabila kita merubah dari Euro 4 menuju Euro 5? Karena kan Indonesia ini ada kemungkinan akan menuju Euro 5. Nah ini seberapa besarkah effortnya itu untuk menuju teknologi itu sebenarnya. Jadi intinya sih emang di after treatment itu seberapa besar atau berubahnya seberapa besar. Khususnya Indonesia sangat akan menggunakan biodiesel. Entah itu FAME dan kemungkinan ke depan akan menggunakan HVO. Nah itu apakah efeknya tuh apakah cukup baik? Membuat menjelek baik untuk bisa diatasi oleh menggunakan after treatment yang secara umum atau perlu ada seperti tadi ada kayak yang tadi ada cost wash code yang berbeda khususnya untuk apabila menggunakan FAME atau menggunakan HVO itu sendiri. Paling untuk sementara itu saja sih Pak untuk pertanyaannya.
Siap, thank you so much Mr. Fajar. Mr. Fajar is under Research Center for Transportation Technology.
Yes,
yeah. So this is clear.
So Fajar-san, the first question about the E20 or B20? B20.
For B up to B40, I think. So because Indonesia is now in the B40, maybe in the next year we go to the B50, but using using the FAME and the HVO actually.
Yes.
There's rumor, not rumor. Maybe we can go to there, but for now still B40.
Okay.
Because for the ethanol, it's still not. We don't know that when we go to the. For now, it's still E5, I think, or E10, but not in Indonesia, but only in Jakarta only.
Okay.
But for the my main question is for the for the B40 or up.
Okay. Thank you for your question. So concretely, I'm not sure the mature technology for applying the the B40 because so generally I have some facing the some difficulties in my presentation. So that it is important point is the lower heating values of the fuels. So some cases they are defective of filter regeneration, and also due to the glyceride formation. This kind of materials is the exhaust gas temperature going down, and also the for utilizing the flame fuel. So just only focusing the after treatment system, I think it is not considerable updates, maybe, might be, but main concern is maybe the engine system and the vehicle systems, like some lava attack. So these kinds of difficulties makes engine reliability and the vehicle reliability. In some cases, the vehicle fire. So to avoid this kind of risks, so I mentioned before, to make the fuel specification like a conventional diesel fuel. It is one of their good solution is to use the HBO. Because the HBO specification is similar to the conventional diesel fuels, but maybe you know well the certain number of this kind of HBO is much higher than the conventional diesel fuels. So we to increase the content and the concentration to the B40 and the B50. So maybe it is necessary to recalibrate the engine emission. But this is the maybe not so difficult problem for the vehicle manufacturers. Because maybe some vehicle manufacturers considering the higher concentration of the diesel fuels in the European market. So European Commission has some same strategies to increase the concentration of the biofuels. But the direction is different to use the HBO, not to use the FAME.
Just one more. You say that if using the FAME, it's lower the exhaust temperature. It will be affect the DOC. I think is it okay? Is it right? Because it's using to the SCR. It's because it needs the higher temperature for the SCR, right?
Yeah, yes.
But if they have HCPO, is it still the same exhaust temperature than the conventional diesel, or is it quite similar with the FAME? Is it the HCPO is how about the exhaust temperature if using the HPO? I think is it
yes.
High or the same as question or lower than the conventional diesel?
Yes. You mean that the same specification of the FAME? Okay. So this is maybe much the solution to use to change the specification, and also the key point is to decrease the glyceride formation and so on. This is the important maybe.
Ya, terjawab. Yang online ada, siap. Mas Fajar sudah terjawab ya, nanti kita diskusi lagi. More discussion maybe in further, because this is very interesting.
Okay.
So from the online, we have from Andi Novianto. So you can read this one, right? Apa kebijakan yang sebaiknya dipilih? So what is the policy that should be choose to improve the air quality, ya? Kualitas udara dan to reduce the pollution, both from the biodiesel and also from the bioethanol. That's the level is minimum Euro 4 or maybe direct we use the EV. So that's you can understand the.
This is a good question. So so I had in my presentation, I have a good opportunity and a good solution to get the ultimate zero emission. Yes. But on the viewpoint of the focusing the emission viewpoint, so that this is the very, very good solution is EV. But industrial viewpoint about to reduce the CO2 and greenhouse gas emission, and also the integration with the exhaust gas emission. Especially at this moment, the I can say the recent and also the at this moment solution is to use the biofuels, but for future investigation. So maybe a lot of big manufacturers is developing the EV for future maybe, and also that I can decide to which is the best solution to use the biofuels and the EV, and also it's something depending on the policy to introduce some charging stations and so on.
Yeah, it's depend to the countries.
Yes,
itself,
country's
right?
policy and
Because
the political
each
policy.
country has different
Yes.
Condition and policy also. Ya, Pas Andi ya, semoga terjawab. Yeah, for EV it will be like in the long
time,
time,
maybe,
right?
yeah, yes.
We will go for the EV. So we have also another EV is like for we can have EV based on the battery and also for the another resource, right? So I went to open. We have still maximum maybe 20 minutes, right? We have left the 20 minutes remain. So if I will go to the offline first also. Please raise your hand if you have any question regarding to the presentation. If not, yeah. Any online maybe? Not yet. So it's time for me. Because as I know that yeah, each country has a different condition and policy for vehicle that's moving on the road, right? And the standard or the Euro 5 and Euro 6, we have some the operating procedure, like if we want to take a test, there are many tests. I think I saw in your presentation, so like idle time and their acceleration time, and also any. How do you see in do we must adopt 100% of that standard if we want to implement, say if we want to test the vehicle to meet the Euro 5 or Euro 6. So say it in Japan, how you can adopt that standard, and what do you have an idea that also can implement in Indonesia? So that's the main point.
Okay, thank you for your question. So difficult question to answer. And also
like the driving cycle and also
yes,
the infrastructure.
Yes, so I mentioned in the my presentation, there are two key emission test procedures. One is the World Harmonized Procedure, WLTP, and also the real driving emissions. And in the past, we used the NEDC cycle, New European driving cycles, but Europe was faced there are some discrepancies between their emission levels in the laboratory and the actual market emission for you driving the customers driving emission. So they decided to implement the driving cycles and real driving emission test procedures. Yes, and I mentioned two objectives to use kinds of the emission test procedures, and also the I just in my personal opinion, to introduce the real driving emission this kind of emission test procedure is dependent on the not only the technology, but also the environment conditions in the market. Very, very difficult to meet the test. So I had a presentation about the test invalid of the real driving emissions. Actually, Japan has facing this kind of difficulties to meet the real driving emission valid. So in summer season, we have some experience to test invalid in summer due to the high humidity. The portable emission measurement have some disadvantages to use kind of environment condition. So considering about this kind of emission test measures in Indonesia, I don't recommend this kind of emission test procedures. And it is maybe clear to use their WLTC test cycles. Of course, maybe the air quality will be decreased in the cleaner and cleaner. So for focusing the Euro 5 emission legislation, WLTC is okay. But you can use the strict emissions like Euro 6. So you have to consider about not only the WLTC, but also the RDE. But to be careful to use the portable emission measurement system in the high humidity condition. And so I amended the United UN Regulation 168 two months ago to have some individual properties to avoid the risks about this kind of test invalid. So it is the this kind of amendment is useful for the other market, not only the Europe, but also the Japan, Indonesia, China, India, Brazil. It's the same situation about this kind of difficulties.
I see. Yeah. Thank you. So, yeah, it's related to the Pak Teguh ya, standardization and pengujian ya. Maybe that's masukan ya. That's for us to see the potential what we must do ya for the testing in Indonesian condition ya to meet the Euro 5 and Euro 6. Any other question? Not yet. Just one Pak Hans, saya langsung tunjuk aja nih Pak Hans. Any other question related to the manufacturing? So I see that after treatment technologies, yes, right? Say it inside the after treatment we have catalyst. It's related to the materials we use, the combination or the method, right?
Yeah.
I see like it is one series or two series of treatment in this technology. Also, how we can manufacture the after treatment. So I just this to Pak Hans. So how do you see the readiness of the manufacturing, the industry, to implement the new technology to produce this kind of after treatment technology nowadays?
Actually the vehicle manufacturers and also the catalyst supplier shifted to the investment to the electrification. In fact,
electrification.
Yes. So for instance, the maybe Euro 7 next emission regulation like Euro 7, maybe the draft document will be released in the next month. But main act of the Euro 7 is keeping the emission limit. So this means that no need to introduce the new catalyst technologies.
No need.
No need.
Okay.
But they focused on the to keep the emission levels in the market. So they implemented some annexes, onboard emission monitoring,
Onboard
and also the
monitoring.
anti-tampering, and also some other emission regulations like brakes and the tires.
Okay.
So they will set the additional annexes. So a lot of many annexes in the Euro 7, but keeping the emission limit.
Oh, okay. But the main is like no need catalyst in the future.
Maybe.
Maybe.
So, and also for future, the European vehicle manufacturers focusing on the to developing the conventional
no emission.
state of the art electrical vehicle.
Oh, okay. Yeah. Thank you so much.
But some different point is to use this kind of biofuels. So, なんだろう、actively reduce their CO2 at this moment. So it is the mature technology and also the good, なんだろう、rapid solutions to get their CO2 reduction.
Yeah. Because for the EV itself, maybe we need more time, like to apply 100% EV in our in international.
Yes. Indeed, European market, European Commission decided to ICE ban 2035. 100 electric vehicle will be introduced in the market.
Oh, okay. So
this is
they already
direction.
will be shut down the ICE, right?
Yes.
Oh, yeah, I see.
But I don't think this kind
how
of
about in
situation.
How about in ICE, yeah?
Yes, and also the some countries like in United States and Japan to keep the both directions named multi-pathway. Indeed, Japanese government set this kind of pathway to introduce not only EV but also the IC vehicles, cleaner vehicles, but to utilize this kind of biofuels and called carbon neutral fuel.
Carbon. Okay, yeah, I think it's enough. Any points? Oh ya, akhirnya nyangkut juga ini. Please, ada mic-nya yang bisa di ini. Just maybe last question from Pak Hans.
Okay, thank you very much. I am from the Research Center for Process and Manufacturing Industry Technology, BRIN. It's very interesting about your presentations. I want to know about your opinion about the CBAM that European Commission make the qualification about the manufacturer, how to achieve the product will introduce to the Europe. They have to recalculate about the emission, something like that. And what is the preparation for all of the manufacturers in Japan or other country that you know? Thank you.
Okay, thank you for your question. So you mean about the European manufacturers keep the introduction of the IC vehicles for the other market, and also vehicle manufacturers is of course under the production of the ICE, internal combustion vehicles, engine vehicles, and also in parallel they have they keep in the production of the electrical vehicles for Europe, not only European market but also the Japanese market and the US market. But I'm not sure the direction whether this kind of direction is set out in the European vehicle manufacturers, but on focusing and considering the Japanese vehicle manufacturers, like for instance, Toyota. Toyota has their keeping the called maybe the Japanese government position multi-pathway to produce the hybrid vehicles and also the plug-in hybrid and EV and also of course the internal combustion engine vehicles. So this kinds of vehicle manufacturers in the keeping the development investment of this all of the types of vehicles. But one direction is to proceed the electrification. But best solution, I'm not sure which is the best solution. EV is the best solution or hybrid is the best solution. But energy consumption viewpoint, maybe Toyota-san is have an announcement to get the best way to energy consumption. The hybrid is the best way to mature the energy consumption in the all vehicles.
Okay. I want to know about the carbon border adjustment mechanism for the manufacturer. Europe will make the new fee for that.
New fee?
Yes. To calculate the emissions.
CO2 tax or something, this kind of.
To produce the manufacturer product, they will calculate. CBAM, carbon border adjustment manufacturer.
I'm not sure the details, but the European Commission decided to set this kind of tax or something, the penalties of the CO2, maybe. And also some countries, maybe I'm not sure that the situation of the United States, because the president was changed from the Bush, to the Mr. Trump. Mr. Trump wants to change the direction of the CO2 viewpoint.
Okay. Yeah, maybe enough ya, Pak Hans.
Yeah,
Nanti
thank you.
kita diskusi lagi next, since we just have a very limited time. So let's give a round applause to Mr. Hitoshi Onodera from JASIC. Thank you so much.
Thank you very much.
Arigato gozaimasu.
Terima kasih.
Dan Yang-san, thank you. Terima kasih. And I would like to conclude this section. So today's discussion underscore the urgency of adopting advanced emission standard and the collaborative efforts. So I want to highlight the collaborative efforts needed to achieve them. So we need to make a collaboration, right? We cannot move just ourselves. We need to move together. And Euro 5 and Euro 6 are not just a regulation. They are a blueprint for a sustainable automotive future. Yes. So my name is Muharram. I thank you so much. Sorry for any mistake. I will close. Alhamdulillahirrahmanirrahim. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Aam. Once again, please give a big applause to this session. As our symbol of gratitude, we would like to deliver a souvenir. Please come to the stage, Professor Chu Supriyadi, representing BRIN, to deliver souvenirs to Mr. Hitoshi and together with interpreter here, Mr. Yano from Japan Automobile Standard Internationalization Center. It was a very insightful presentation, also very interesting discussions. Quite a lot of information, very important. Thank you so much. Thank you so much, Dr. Onodera Hitoshi, for sharing with us and coming all the way from Japan to be with us today. Okay, once again, please give big applause to Onodera Hitoshi, and then of course, next is for our moderator, Dr. Nana. Thank you so much for the presentation. Very interesting. Please give warm applause once again for this session. One more group photo. We hope to have more collaboration together with Japan Automobile Standard Internationalization Center. Ladies and gentlemen, the morning session has concluded, and it is now time for a short break before we continue with the parallel oral sessions. The morning session ran behind schedule, but since our time today is limited and we have quite a long list of presentations, the next session will still begin at 1 p.m. as planned. Please adjust accordingly and ensure you are ready before your session starts. As a reminder, I would like to share a few announcements regarding the parallel oral sessions as follows. Yeah. Online participants, please make sure your microphone is muted and only unmute when being asked or very necessary. Online participants are required to join the virtual room 15 minutes before the session start, and please rename your Zoom name to article ID_name_session. Online participants must activate the camera and use the official ICSEEA 2025 virtual background. Online participants, please choose a quiet, distraction-free location for attending this conference and ensure proper lighting for your video setup. During parallel session, participants are expected to remain in their respective rooms and stand by waiting for their scheduled presentation. Please avoid taking screenshots or photos of presentation slides belongs to other presenters during the parallel oral session. Offline participants, please check the program book file or a reference of your respective room. Offline participants, please note that slideshows will be managed by the committee and cannot be presented using your own laptop. Kindly ensure that you have uploaded the correct file. Online participants, the committee will assign you to your respective room. Once your session is complete, you are welcome to join a different room by clicking Request to Enter for your desired breakout room. And then, after you request, the committee will take you to the breakout room as you requested. And maybe one more, there will be a moderator and timer in each room, and please follow and do your presentation following the time provided. Okay, and next we have I would like to show you the parallel oral session location for offline, starting from 1 p.m. Here is sustainable energy here in this ballroom and ground floor. This is ground floor. And then for green manufacturing is in Sono Keling room in upper ground or UG, one floor above this floor, this floor. And then for online participants, we have sustainable energy, room 1 online. And then sustainable transportation is room 2. MSTQ or measurement, standardization, testing, quality in manufacturing is room 4. Okay, next. Next is for the second session, starting from 2:30 p.m. is sustainable energy, continue here in this room. And then sustainable transportation in Sono Keling, upper ground. For online session, sustainable energy room 1, green manufacturing room 3, MSTQ room 4. And next. For the third session, starting from 4:15, because we will have around 15 minutes coffee break, we will have offline here in ballroom for green maritime, and then online for green maritime for room 5, sustainable energy room 1, and green manufacturing room 3. You can check on the program book if you missed this part, right? Okay. All right, so since some participants and guests join us at a later time, we would like to capture today's moment once again with a group photo. And this time, to ensure everyone is visible, we kindly ask all participants to come to the stage, maybe some on the stage here and some in front of it, so we can take group photo together. Sorry for the inconvenience, but please, we can make another group photo. And this time we would like to invite everyone to come to the stage. Maybe some of you can be on the stage here, and then some of you can be in front of the stage. We would like to welcome all keynote speakers, head of research centers, head of research organization of energy and manufacture, and then our sponsors, representative of sponsors, and all the audience. Since now we have more time to arrange everything so that we can have picture on the stage. Yeah, please, on the stage, maybe keynote speakers, and then Professor Chu, and then Chairman ICSEEA, and then research centers. Yeah, some of you on the stage. And then some of you can be here in front of the stage. Please help to make sure that everyone will be visible. Yeah. We will have only around 30 minutes of lunch break, so we need to do this quick. Yeah. Okay, can you, sir, could you please move closer? Yeah, everyone, all participants, and maybe some of committee also can join, except operator. Can you please be closer to each other? Yeah, so that we make sure everyone is visible. Maybe more, you still have some space between you, so can you please move? Lebih mesra, lebih dingin AC-nya, jadi boleh biar anak maksimal. Maybe can some of you like apa sih namanya, zigzag, apa zigzag? Masuk nggak, Mas? Can you see everyone? How about me? Where shall I go? How about me? Can you, am I in the frame? Oh, okay. Okay, so our theme is sustainable future, right? So maybe later we can make a video too, saying sustainable future together. But first, photos. Okay, 3, 2, cheese. Okay, maybe put your hand in the air. This. Yeah. One more time. 3, 2, 1. Oh, it's better without it? Okay. Okay. Video, yeah. Okay, so we're going to make a video. When we say, when I say ICCEA 2025, you say for a sustainable future. Sustainable future, okay? Together. Okay, let's practice. Maybe we need to turn down the music. Okay, when I say ICCEA 2025, and then everybody say, for a sustainable future. Yeah, okay. As loud as possible, okay? Because we are all hungry here, I know. Latihan dulu, yeah. Let's practice first. All right, ICCEA 2025 for a sustainable future. Okay, that was good actually. Okay, one more time, better, okay? All right, ready? Oh, no. Oh, okay, oh, let's wait for the background to be visible. Okay, then maybe we need more photos. Okay, is video ready? Recording? All right. ICCEA 2025 for a sustainable future. Woohoo. Okay, done? All right, once again, okay? Okay, please give a round of applause for all of us for a quite exciting morning session. And then we are excited to welcome our next session at 1 p.m. Please make sure you enter your desired room. As for the presenters, please get ready 15 minutes before 1 p.m. Thank you. Aku